So we have around 130 participants right now. Good strength.
Yeah, more than 130.
Yeah.
Okay, so I guess Vikas has given us the flag to go on. Okay, so good morning, everyone. Good morning, all the participants. Good morning, all the enthusiastic people, those who actually joined here and they are with us from yesterday only. As we all know, this particular event is all about understanding the technology in a better sense. So in yesterday's session, we have very expert talks, expert speakers, those who have actually enlightened our knowledge, or you can say the current knowledge about the technology. In today's time, or even if we see the past 2 decades, technology has actually played a very crucial role even while creating an ecosystem, maintaining that particular system, and flourishing the independent services into that particular ecosystem. So, but the term technology is actually evolving in a very dynamic pace or in a very dynamic speed. So to cope up with all these, even all the domestic ecosystem, they also need to upgrade themselves, re-engineer themselves. And this particular initiative is all about that only, that what specific tweaks we actually needed in our ecosystem when it comes to MSME, when it comes to new businesses, and how to actually understand those tweaks. So this particular initiative is all about to understand those tweaks and to adopt those tweaks so that they can actually have a good kind of cope up mechanism, or you can say cope up strategies, which is something missing in current ecosystem. And that's why in yesterday's talk we have witnessed that out of 100%, around 90% of the startups or new ventures, they fail in the first 3 months. So today we have with us Miss Priyanka Chand Bhatt. She works in this particular field only where she actually understands, she analyzes the technology course orientation. And when it comes to technology, trust me, our understanding of technology is very primitive in nature. And why I'm saying this, because we always consider a technology as a whole component. Somewhere it's our deficiency to understand a technology as a combination of multiple components having their own specific features, having their own specific requirements. So Miss Bhatt actually works in the area of patent mining. She has published papers, scientific papers, research papers in that particular field only. Also, she has an interest in cloud computing and mining, text mining, cloud computing, and all sort of things. Now, today, Ms. Priyanka is actually going to help us to understand that how to actually know the course of a particular technology. And as we all are very much fascinated towards the competitive technologies like IoT, blockchain, so we'll talk around that only. And then hopefully after this particular session, we will be in a better position to understand what will be the course of blockchain technology in next 5 years, or what kind of an application industry will be witnessing in next 5 years. So once again, I thank you all to be here. And unlike yesterday, we will keep this session a little bit interactive because this is a workshop model. So those who have a questions and queries in between or by the end of this particular session, we request them to raise their hand, and then we will we'll allow them to unmute themselves and to raise their queries so that we can actually accommodate all sort of queries and questions, right? Once again, thank you very much. And I'm handing over the podium to Ms. Bhatt. Thank you.
Thank you, Dr. Vinayak, for the introduction and for the introduction of this session as well, that what we are going to do today. So I'll just share my screen first, just a second.
Yeah, even before sharing the screen, Ms. Bhatt, do you have any prerequisite, any expectation from the audience? Because we have a very large audience, and
I was going
these
to talk
audience are
about that
coming
after
from
sharing my screen.
different
Yeah.
background.
Yeah. 1 second. Let me
Yeah.
just share the screen first. Yeah. So about today's session, I'll be talking more about patent mapping, technology trajectories, all these big words. I think you must be guessing the audience members, but I want to know about the audience. Are they all students or entrepreneurs or what's the mix
So
up
I
of?
guess we have means we have all sort of audience here present. I guess majority of the audience, they are coming from the student side, right?
Okay.
Because they are the young brains. But again, they are the upcoming entrepreneurs, right? So
And I
simultaneously,
appreciate if students can, be more interactive in this whole
right,
session. I encourage all sorts of questions, and I'll be asking questions in between. So I want students to raise hands, audience to raise their hands, and I might be cold calling some names, or I might see the raise hand and ask someone to answer or discuss something in between. So today's session will be more interactive, and let's see. So about today's session, patent mapping, technology trajectories, and everything, I'll explain these terms in the session afterwards. And about before beginning this session, I'd like to ponder upon about the yesterday's conference. I was going through the YouTube link of the conference. I was skimming through the sessions about yesterday, esteemed guest speakers and everybody. And everybody talked about how new ventures should start, what they should focus on, think about the idea, think about your niche, think about your, it's all like think, and how do you analyze your market? It's all about, like you had said in a discussion, Dr. Vinayak, about the anticipation model.
right.
It's all about anticipation. But is there a scientific approach to that anticipation? I would like to add to that. So before beginning this, I would like to share that IBM and MIT are already working upon this scientific process of this anticipation model, I would say. I may not be well versed with anticipation model, but like it's like I start a new business and I start thinking, I want to learn something, and what would I begin with? I would just, collate information from my friends or somebody. Or I want to start a new business. I want to see which technologies I can add on to them. And how do I begin with? I just anticipate, or I just look at the trend, look at the big companies like that. Or sometimes wrongly anticipate my competitor, like the last session yesterday. So how do we scientifically approach to this, identifying our competitive technologies, our competitors, or the technology that we will be adopting in our businesses? So that's what I'll be discussing about in today's session. And one more interesting thing is, in the whole session, I only heard the name patent twice in the whole workshop yesterday. One was in, I think, Mr. Nikhil's presentation, and one was in Dr. Khatwani's presentation. So they both discuss about, when you start your venture, when you want to see which technologies you want to adopt, which competitive technologies, or which tech competitors you want to adopt, see. So you just go through the patents of different companies or different technologies. So only 2 times I see the term patent. But I want to ask the audience that, do you think when you think of patent, how do you correlate it with the new ventures, or how do you correlate it with your business idea? Can you correlate the term patent and your business idea together? You can just write in the chat. It's okay right now. Anyone? Nobody?
Participant, please feel free to
Okay,
interact.
you can
Yeah,
write anything. You can just say no, or you can just say you cannot
right,
correlate.
right.
It's
There's
okay.
no right or
No need
there's
to
no wrong
be, yeah.
answers.
Okay, yeah. Okay as an answer. Yeah, patent is a legal protection. Yeah, that is. But I'm asking, can you, when you think of a patent and when you think of a business venture or a new business venture, can you correlate these two? Can you think of the correlation between these two? Your a patent and a new business venture or a new business idea. Okay, Mr. Ravi says, I'm just thinking about how to patent our idea. Okay, good. So you are asking the question that how to patent our idea. Okay. I'll wait for one or two more. Okay, no one can take credit. Yes, okay. Yeah, patent is a legal right to an invention. That is one thing. I'm not asking about the definition. I'm asking about the correlation. Suppose you have to begin, you are thinking of starting a new business, or you have an idea of starting a new business. And I say patent. So can you correlate these two terms or these two things? Okay. Okay, fine. Mr. Assad says, with novel idea, technology, process, or service, one can ensure business sustainability with patent technology or process. Okay. It's important to patent. Okay, it's important to patent so that no one can copy. It's important for business. That's good. Ms. Komal had said this. Yeah, that's right. But what I want to convey is, so they're two are related. Yes, these two are related. Yeah, of course, these two are related. And what I want to focus on is when you start a new business or when you think of starting a new business. So that time you are the base is the idea, right? And for patent also, the base is the idea. Patent is you are patenting your idea, you are securing your invention. And business is like you are giving a nudge to your idea to go into the market, right? So how these two are connected, that you have an idea, you secure that idea with the patent, and you go into the market, and that's when it all starts. So this whole session will be about how the patents can help you help new businesses. How can you identify technologies? How can you identify the path of a technology? Or how can you understand the evolution of a technology? I'll be discussing about blockchain in next few slides further in this session. And I'll be asking a lot of questions about blockchain from you guys, because I was told that yesterday a lot of you had wanted to know about blockchain a lot. So let's see how that goes. And so let's begin the session. So outline, what I'll be covering in this session is, first I'll discuss a little bit about patents, what a patent is, what is patent data, what a patent looks like, and how can we analyze the patent for understanding the technology concepts such as innovation, life cycle, technology trajectory, and everything, and how these two are connected, like I asked you. So all these big terms like trajectory, path, innovation, technology path, technology trajectories, all these will be, we'll connect all these, we'll explain all these in the session. And at the end, although I wanted to discuss more technologies in the case, but I think with the time limitation and the interest of audience, I have chosen just blockchain and its application. Also because I'm also working on blockchain patents, analyzing the blockchain patents. So I'll discuss that later in this session. And let me see if there are any questions right now. Before beginning, if you have any questions, you can ask, or anything you want to share or something. Okay. So let's begin. So what is a patent? Yeah, almost all of you know this, is that patent is a right to protect your invention, your ideas, anything you design, anything you create. You can secure that invention, you can secure that idea with the help of a patent by publishing a patent. And when you publish a patent, you are becoming the inventor of that patent, and the company you are working in that time, or the country you are in also becomes associated with that patent. So a patent, not only it discusses the innovation or invention of your idea, but it also represents your country, your company, your region. So when you think of a patent, just don't think it like it's just your invention output. It also is a representation of how a country is doing in terms of innovation, how a country is doing in terms of how an organization is doing in terms of innovations, how many patents an organization is having. That does not mean that, for example, if a company has lots of patents, that means it has lots of innovators, it has lots of inventors, or maybe one inventor is publishing a lot of patents, and so on. More patents a organization has, more innovation curve it has. More patents a country has, more hold it has on the innovation landscape. So when we talk about innovation, is it only technological? I am asking this question. When we think about innovation, since this session is focused on technology, but I want to start with, is innovation strictly technological? Can somebody give me an example of innovation which does not include technology? You can write in the chat box. Yeah, innovation is not based only on technology, right? But can anyone give me an example? No example? I'll discuss the types of patents later, but first I want to show the example. Can somebody tell me what this is, the diagram here? Or let's just say this one. What is it? It is a Nike patent for a Nike shoe, right? Yeah, any design, yes. That's a design. That's called a design patent. Mr. Aman said any design, yeah. Nike logo, yeah, logo can also be patented. That comes under the design. So when we think of patent, it's not just about a phone or electronics or blockchain or something like that. It can be anything. It can be any design also. So patents are of two types, actually. I'll just go here. Three types, sorry, and utility, design, and plan. But we don't discuss more about plan because it's more focused on research scientists working on agricultural, where they can reproduce a plant by just gene mutation and not from the hybridization of those things. But utility and design patent, they are more discussed, more researched in the field of technology, field of innovations. Utility is where any process, any machine, any software which can be utilized for social good or for a process comes under the utility patents. And design is when you can design any object, when you can, like an IKEA chair, Nike shoe, like I just show you, or a computer screen icon, or Ms. Kritika said Nike logo. Yeah. So these all can come under the design patent. So one thing I want to share with you guys is the top companies in technology patents and design patents. And you can see yourself on the screen that in the technology domain, IBM has the highest number of patents. And this is the data from 2020, and current data may be more. So it has more than 9,000 patents in 2020. And after that is Samsung, LG, and so on and so forth. And in the design patent, you can see Nike, and then we have Samsung and Apple logo, and so on. So here, the coffee machine patent. Okay, we don't have any. I'm closing the chat window right now. So yeah. So here I have also added some classification and description numbers. So I will discuss all these in detail in the later session. So when we discuss about the data about patent, so why I'm giving you the basics of patent right now, because before understanding a trajectory, innovation of how we reach on the innovation of a technology by patent analysis, I want to give you the background of a patent also. So every patent has a drawings of your innovation or invention. So for example, here are the coffee machine design. And then we have Nike patent. These are all, without technology, no technology, just the design patent of the Nike shoe. So here is an example of a patent, first page of the patent document. So I want to ask the audience that, is any one of you familiar with the process of patent publication or patent, writing a patent, or have seen a patent before? Just say yes or no. No, okay. Anyone? Okay, no, okay. Okay, we have lots of no's here. Any yes? Okay, fine, no problem. So here is just the first page of a US patent about, wait, I'll open a laser. So here you can see United States patent, that is a patent issued in United States. And here is the name of the author, last name of the author, Chen. And you can see here is the title, Mobile Wallet and Digital Payment. That's the title of this patent. And it's more like a research paper or a magazine. Have you seen, is any one of you familiar with the research paper? Just say yes or no. Yeah, yes, I have a yes, okay. Okay, yeah, sure. So when you see a research paper, you also, know that there is a title, there is an author, we have a publisher, like that. So it's similar to, wait a second, okay. Yeah, we have lots of yes for research papers, okay. So patent is also like a research paper, but research paper is more like, more scientific and, wait a second, I'm sorry. So research paper is more scientific, based on your research, and patent is more invention based on your invention. So here we see that this is the first page of a patent, same like research paper. We have a title, we have authors, we have lots of, instead of authors, we call them inventors. Just a second. Yeah, so here. So instead of authors, we have inventors, and assignee is the company of inventors. It can be one, it can be, maybe because there are 3 inventors, so maybe more than one company, but here they are just from the Microsoft. And then we have some information, and there is, on the top, you see a patent number and date of the patent. Just like in a research article, you see volume number, issue number, like that, to just give a unique indicator for the paper. So here it's patent number, which is a unique for every patent. And then we have a date of patent. So here, this date is October 18, 2011. And then we have here the filed date is September 10, 2007. So what these 2 dates signify is, because patent application process takes a long time sometimes. So the patent was first filed in 2007, and it was accepted, or you can say finalized, in 2011 by US Patent Office. So it took almost 4 years from application to publication. And sometimes in that period of time, the patent documents are provided online, but they can be applied but not published, but they are still online for you to assess them, maybe while they are in the process of revision of that patent, but you can also assess those patents. You can also cite those patents. You can also use those patents for your own understanding. And then we have these codes, like I showed you before in the coffee machine patent. These are called classification codes for patents. And I don't know if you have noticed in a library books, when you borrow a book, on the book is a small barcode information, and there is a number on that. So that is also a special code for the subject domain. Like if it's a chemistry book, you go to the chemistry section in library, but there are small numbers also, numerical or alphanumerical. So these are all categories assigned to each subject domain, like chemistry, biochemistry, chemistry. If chemistry is suppose A, and biochemistry will be A1 or something. So here also, we have technologies that are, the numbers are given to technologies. There are codes given to technologies and the sub-technologies, like if it's an electronic, then we have under the electronic, we can go like semiconductor or something, and go on. So H04 may indicate a code for electronic technology, electrical technology, and H04M may indicate wireless communication or something. Yeah, I have a hand raised. Wait a second. I'll just finish this this page, and then I'll ask Ms. Diksha to talk. Just a second. So, and then we have references cited. These are very important because here is when you write a research paper, you cite some articles, you read some articles, and then you cite them. So similarly, when you write a patent, you and also I want to add here that whenever you have you're understanding some knowledge, when you are trying to give some knowledge to somebody, when you say something or when you express that knowledge, where is that knowledge coming from? That is coming from your previous sources, right? So similarly, in this process, when you write a patent, when you write about a technology, you are not starting from the scratch. You are reading or you are skimming through already existing documents to understand them, to understand the whole process. So you have to cite, you have to address these, you have to cite those documents in your publication, whether it's a patent, whether it's a research article. That's the ethics also. That comes under the ethics also. So here we see US patent documents that are cited, and then we have foreign patent documents from Japan, Korea, JP and KR. And then we also have some research paper that is being cited by Jacobi. And then starts the abstract and the design of this paper. So I had a hand raised, and wait. Okay, it's fine. So anyone wants to ask anything by now? Does anyone have any question?
Audience, if you have any questions, please feel free to raise your hand so that we can unmute you and you can ask your queries.
Okay, I have a question in Q&A. Mr. Fuzel has asked, how are patent rights enforced? Well, how are patents right enforced? Okay, that first thing is that we are not talking about patent right in this session, but I'll answer this question, is that patent rights are enforced by governments, by patent offices, and every region or every country has different rights. Like for example, in US, if you file a patent, it's yours for 20 years, and then you have to renew it or something. In India, it was 60 years, and I think now maybe it has increased or decreased a little bit. So there are various different laws for that. There are various different committees for that, and these are enforced by the governments, I would answer. So any more questions? Is it looking like a research paper? Yes, it looks like a research paper, but in research paper, you have you have a research gap, you have an analysis, you have a theoretical implication, something like that. In patent it's more like your design of the idea, your design of your prototype, and what do you claim from that design? What's that design going to be? How it is going to be utilized, or what's the design? How the design is unique? You talk more about the uniqueness of the patent. What is the process to have a patent? Well, that's a different discussion. Okay, we can say like research design. Yes, it's like a research design. You have to build upon your idea. You have to make your idea concrete. You have to design, like I showed you the Nike patent. So to design a Nike patent like that, like this, you cannot just stay, you cannot just, sit in one day and make this whole design. This is the process. This is the whole idea generation process. So yes, it is like a research design. To have a patent, you first need to have an idea. You need to start working on the idea, maybe build a prototype or just design a prototype, and then you need to apply to the offices. And to be honest, when you apply for a patent, it's an expensive affair. So you have to think about your budget. You have to think about all these things. Can I discuss details of my creation with the potential investor before filing a patent application? I guess so. Yeah. Okay. If you have a concrete idea or prototype of your product or your idea, I think you can go ahead. So they know that you are serious. I think your investors will understand that you are serious with your innovation. And because patent application also takes it's expensive affair, so you have to discuss about the budget and everything. Because one more thing I would like to add here is when you I will share it in the next session. I have these slides. I will discuss it there. So okay, I'll move forward from here now. Okay, we have another. So I also wanted to share a little bit about Indian innovation landscape, that which companies or which industries are doing better in the patent landscaping. And these are some companies. This one is the report 2021 report about Indian patent ecosystem. So Hawaii, CSIR, IIT Bombay, Larsen and Toubro, Ericsson, Bayer, DRDO, all these mix of private and government institutions and companies are actually building innovations and patenting their innovations. So moving ahead, so we talked about patents, and I showed you a patent page, first page of the patent. But how do you search a patent? Where do you see for a patent if you want to learn about a patent? So just like a research paper, I think many of my audience is well versed with research papers. So okay, I have a hand raised. Okay, I'll take this time. Diksha, you're allowed to talk. Miss Diksha? Okay, I'll move ahead from here. So same as research papers, how do you, when you search for research papers, where do you go? Google Scholar, Science Direct, Scopus, AppSco, lots of, or just Google something. So similarly, for a proper patent search, you need to go to patent databases where all these patents are stored. So I have listed some free patent databases where you can just go through the patents. Google Patents. We have WIPO, Patentoscope. WIPO is World Intellectual Property Organization. Then we have SpaceNet, which is a European Patent Office website. And we have USPTO, United States Patent Office, Patent and Trademark Office website. And we have PQAI. This one is for priority patents. I will discuss in further slides. So all these websites are free to, you can just go to these websites, you can just explore, search anything you want to search about, electronic vehicle, autonomous vehicle, blockchain, or anything you want to search about. Just click the term and just see what you get. And you can just do anything with the search results. Some of them may not have a very good patent analytical utilities, but like USPTO provides actually free data for, to do some text mining or for you to do anything you want with the data. And then we have three major patent offices where you can apply for the patents. One is USPTO, of course, United States Patent and Trademark Office, the European Patent Office, and then Japan Patent Office. These three are the major owners of the patents. Like if you have a patent in USPTO, you have more rights to your patents like that. So mostly if you see, sometimes what happens is if I want to write a patent or I want to write a, After these two slides, I will answer the questions in chat box, so you can write down some more questions in the chat. So if I am writing a patent in India, for example, I am in a company in India or I am an inventor and I want to publish a patent. And when I write in the patent office, so I apply in Indian Patent Office, and then my invention is secured in the Indian Patent Office. And then later on, I also want to, apply that patent in USPTO because I want it to be more visible, more secure. So later on, after some time, when I have secured my patent in my Indian context, I also want to go for the USPTO. So in this case, what happens is I have my patent in Indian office, I have my patent in US office. So what happens is there are two copies of my patents, right? So when you have two copies of these patents, the same invention, one is in Indian office, one is in US office, we call it a patent family. We call this cluster a patent family. Or I can say maybe I work with someone else. Two inventors are working together and they invent something and they file a patent for it in one region, and then the other inventor does something similar and files for it in another region. But the first patent is from India, for example. So that becomes the first priority of that whole patent family. So what I want to address is when you search in a USPTO database, you will find some patents that have mentioned priority. So that's what a priority is. Priority patent is the first patent filed in their respective regions, right? So, and you can also search for Indian patent in Indian IP website, but you can only search for the patents there. There is not much to do in this, and you cannot even analyze or do anything. You can just search and just see, not much to do there. So moving ahead. Yeah, so now I want to ask that this is just a lame, not lame, just the basic new product development process that, you begin with idea generation, then you have you try to develop a prototype, you test it, and then you begin your marketing strategy, then you go into your product development, testing, and finally commercialization. So here I want to ask, which stage of this whole process do you think patenting should be done? I'm asking the question to the audience. Miss Diksha, if you want to ask something, just please write in the chat. Don't raise your hand a lot because
So I guess, Ms. Bhatt, those who want to ask the questions, they can raise the hand and then we can unmute them.
Yeah, I know, but Miss Diksha, I already unmute her, but I think maybe it's some mistake or something. Okay, so I just want to ask that in this whole process, where do you think the patenting should be done? Or where do you think you should start building your patent at when you are starting your business? Do you get my question? Anyone? Idea generation and prototype, Miss Gitanjali. Idea generation, okay. Idea generation. Miss Diksha, okay, I'm just trying to allow Miss Diksha to talk. She has been raising hand for a long time, but you can unmute Miss Diksha if you are listening, you can unmute your mic. I think it's a mistake from, I don't know, maybe it's okay. Idea generation. So we have, oh, okay. Someone says, Miss Mansi says before commercialization. Okay, idea generation. Okay. Yeah, so yeah, first and before commercialization, because without testing, we don't know how reliable it is. So I think before commercialization, that's a good answer. Yes. So ideally, it should be at the beginning of the process, like when the idea is generated, when your prototype is developing. So you just try to secure your invention so that, sometimes you fear that maybe once your product is in market, somebody may patent it or something like that. So ideally, it should be done at the first stage, beginning of your prototype testing or development and testing. But I really like this answer by Mansi, that because without testing, we don't know how reliable it is. But patent is not about the reliable. It's much about reliability, but it's more about your idea. It's more about your prototype, what you are developing. So ideally, it should be done at the first stage, but sometimes it can be done at any stage of this whole product development life cycle, because many times, new businesses, they don't know that, they don't know when to start a patent. Sometimes you don't know even that you have to file a patent. Yeah, it's more idea preserving, Mr. Rishabh. Yes, that's the actual, yeah, that's good one. Idea preserving rather than, yeah. So you can do it at any time, but ideally, yes, of course, the first time. And because many times you don't even know that you should you should file a patent for your application. So now we talk about patent analysis, but before going here, I just want to go back to the patent page. Here I have discussed the patent contents are of two types, structured and unstructured. So I just want to go to the patent snapshot that I showed earlier to give you guys an idea of what a structured text is and what an unstructured text is. So anyone from in here with the technical background with data mining or so, or text mining or something like that? Anyone familiar with text mining or mining perspectives of a document? Yes, Alok Sharma, okay. No, okay, no, one is no. Okay, so when we talk about analyzing a patent, we have two types of data in a patent. One is the structured and one is unstructured. What does that mean? That means one is, has anyone heard the term metadata? Anyone of you know about, not metaverse, metadata? Because metaverse is very hot right now. So metadata, anyone of you know about metadata? Alok Sharma says yes. So what is it? Kashif says yes. Okay. So what can anyone tell me what a metadata is? Data about data. Yeah, it's data about data. But what is it? What is it actually? Okay, I'll just move forward from here. So metadata is when data about data, which means that we have a lot of data in here in front of us in this US patent page. But how do we store this data in a database? Some of you who might have worked on a database might know that how do we, data that describes about data. So how do we save that data? We have some attributes. We have some attributes in our database where we save, like, name of the author should be a string value, like date should be a date value, some patent number should be numeric or alphanumeric, something like that. So all these are more static, right? So all these metadata are mostly static, like we have a title, we have an inventor, we have assignee, we have application field, we have date of patent, we have the IPC classification numbers. All these are static. You can enter, you can make a entry form and you can enter into your database. This is all structured data where you can just, go through the document and just see and understand, yeah, okay, title is here, inventor is here, assignee is here, and so on and so forth. But what is unstructured data is the text in the patent, is the diagrams in the patent. How do you make sense from these things? Because sometimes if I, for example, here we are writing, the patent is about mobile wallet and digital payment. So when I write, for example, if I am writing a patent on mobile wallet and digital payment, so I write some international codes in IPC code like H04M, G06Q, what I think is best to my knowledge. And I cite some patent documents and I cite some research articles, and then I write my whole patent. And when you want to analyze, when somebody else wants to analyze these patents or patent, or somebody wants to, get from the database, get something about mobile wallet or just about digital payment, what you say here in the diagram, in the text, you cannot get from the structured data. So you do text mining to get more keywords, more information from the data, from the written data. So that is the unstructured data. So moving ahead. Oh, sorry. Okay, moving ahead. So here, it's structured data is your, static data, and unstructured data is the narrative text. You can also mine the patent title and abstract and descriptions. So how does patent analysis work? Like I show you a patent, but it's just a single patent. If you search for digital wallet on any patent databases that I give you a link of, you will get thousands or 10,000s of numbers. You will get lakhs of numbers. So how do you make sense from that data? How do you analyze that whole lot of data? So patent analysis follows a process. I'll discuss about this process. Is that first you select the patent database, whether it's USPTO, whether it's EPO, WIPO, whichever data. All these are very thorough databases that you can go through. If you search for blockchain, maybe you will get 5,000 or 6,000 patents. Mr. Fuzel asked, what roles does WIPO play with regards to patents? WIPO is not only a world, just the organization, but it also, you can also apply your patents in WIPO, international patents, just like USPTO. And they also have a database, like I mentioned before, Patentoscope, and you can just search and analyze your patents. They also provide lots of exhaustive reports about latest innovations and in terms of patent landscaping. So first we select the database, and then we retrieve the patents. How do we retrieve? With a search, just like you search a paper, or just like you search on Google. But on Google, you can be more like, you can write about or you can write a sentence, but here you have to be more structured about your search query. So you have to identify important keywords, important IPC codes. And then once you retrieve the data, once you have obtained, for example, if I search a patent and then I search for a patent query, and then I get maybe 10,000 data. So how do I analyze those data? How do I, collate all this data? What process should I be doing to get sense of it, to visualize this whole data? So that's where we transform it into structured data. We extract those structures, and then we finally do the patent analysis. And now we are talking about patent analysis. We are talking about patent, but what actually patent analysis does? What you can make? What is the making sense of patent means? So you can do patent analysis for identifying the trend of technology, like, what's up, what this technology has been up to. Or you can identify the novelty, like how novel a technology is. Is it just, just hopping on the previous technologies, or is it something new that has come up from the previous technologies? Or you can just roadmap the whole technology, like how this technology started, how it's going, and was there any discontinuity in between, or was there any major spurge in the technological innovation? You can create anything you want with this patent analysis. You can identify important companies. You can identify and by identifying companies, you can identify your competitors. And also you can forecast the technology. When I say forecast the technology, how do you forecast the technology? So we have neural network methods for technology forecasting. That is more technical. This session is not going to be too much technical, although I'll be discussing the patent analysis process in next few slides, but I'll not give the mathematical basics or text mining basics in this session. So I'll just touch up on the scope of the patent analysis. So for technology forecasting, there are neural network methods, mining methods, or statistical methods to identify the curve of technology in the future. So there have been some studies also on this topic. So if you want, I will suggest you some papers or some articles to read on that. So moving further, yeah, just as I said before, so what are the approaches? There are visualization approaches, and then there are text mining approaches. Visualization approaches, it's just, you identify the whole patent network, you identify clusters of technologies, and then you have text mining approaches where you can use NLP approach, natural language processing. You can mine through the abstract and description of the patent. You can identify the keywords from the patents, from the patent text, and you can identify the ontologies, domain ontologies from those. And you can apply neural networks to, project the future of a technology in further 5 years or 10 years or so on. Here I will also, before going on, now next is the technology concept. I will give a 5-minute break here. I think we are 1 hour into the session. So I will ask participants to discuss or ask questions. So before having a break or before going further, I just want to add something. When Apple was introducing iPod, iPod, what iPod is, right? That small device with music. So when Apple introduced that iPod, before the introduction of iPod, Apple started patenting about that technology, about that particular device, because it was new that time. And one interesting thing is when you get to know about a product, about a technology like iPod. So for example, today you learn about the term iPod. So how do you search about that technology? How do you search the background of that technology? Because when Apple introduced iPod, the patents related to iPod didn't mention iPod. The patents did not have the term iPod in them. So how do you start searching about that? So it was a very interesting article I read one time, that some researcher, by analyzing the patents of Apple in a particular time period, projected that Apple is coming with some device like this. He didn't know the name, he or she, they didn't know the name of the device, but they projected by looking at the patent landscape of Apple that they are coming with a device like this. So why I'm telling you this is, by analyzing something like this, you can identify, where in market you want to be. Like if you are seeing some big incumbents or big companies applying patents in particular domain furiously, in 5 years, in last 10 years, not 10 years, now the technology scope is so less, maybe last 5 years or 2 years, you try to understand what this company is up to, what they are up to in technology innovation. And you can think about how you can come up with in your new venture, whether you want to be an ally to that innovation or you want to be a disruptor to that innovation, right? So with that, in the next session, I will discuss about technology trajectories and technology life cycle and the path dependence of technology, the basic concepts. And I think I will take a 5-minute chat session here to answer your questions. You can write into chat or you can just raise your hands. Okay, we have some questions. What are the cons of current patent analysis, and are there any free tools or databases available for patent mapping? Okay, patent mapping, free tools, you have visualization tools like SOCNet, you have WOS viewer, but for that you have to extract patent from databases. And then you have to create something, create an Excel, or maybe create a network from your patents. I will discuss those things in future slides, maybe after the technology concepts. And then after that, you can use that data, you use that structured data into those patent mapping tools. Okay, what are the cons of current patent analysis? Cons are because the patent search is more keyword dependent. So it may be like your keywords may not be not enough, or it may be a lot. So it depends on how you search your keywords, how you plan your search strategy for a technology searching. So first step is that. So be careful with the keyword structure, because I'll give you an example of blockchain because I'm working on it. And what happened when I started searching for blockchain patents is I would just write blockchain in the search term, and I would get a lots of results. I was happy. But what happens is when you start going through the results, you find out the old results from cement domain, from polymer domain, and you get confused that what is this? What's that? So because they also have something called blockchain based on polymer reaction or based on some cement binding concept. So you have to plan your search strategy based on that. So that's the one thing that it's not it is a con, but it's more like you have to be good with search strategy. Any more questions? Are patent provided for lifetime, or we have to renew after some time? Is patent apply? I just discussed about this in few slides back, that it depends on different countries, different laws of the countries. Like in US, it's for 20 years. Like in India, it's for 60 to 65 years, and then you can renew it. And for example, if an inventor dies, and after that, it's still the patent is still with the inventor for next 60 or 20 years, like that. Is patent only I just discussed this. It depends. It's a region dependent, and if you want complete world, maybe WIPO, you can go for that. Why blockchain only used for crypto? I will discuss about this in detail after the technology concept session. I'm going to ask lots of questions to you guys. What are the resources for blockchain and how to master it in college days? Yes, I wanted to discuss this. So yeah, let's maybe discuss about that. So what about blockchain you want to know? What like before, Mr. Fuzel has asked why blockchain is only used for crypto. So when you are asking me about blockchain, what do you really want to learn about? Are you interested in the cryptocurrency part, or do you know what a blockchain, do you have an idea of what a blockchain is? Can you answer, Mr. Fuzel and Mr. Kashif? Yes. So when you think about blockchain, so when you think about blockchain, what are you thinking actually? When you say blockchain, you want to learn blockchain, what are you thinking? What first comes to the mind? The thing can be changed or be deleted. Okay, that's because of the distributed ledger, decentralized ledger. It's a chain of blocks, so that's why it's called blockchain. We can only add in the blockchain. Yeah, that's right. But blockchain is just a node. So what's the difference between blockchain and a cryptocurrency? Is there any difference for that matter? Is there any difference? Or technology for storing database? Okay. So is there any difference between blockchain and cryptocurrency, or is there no difference, or is there any difference? Just I need some answers. Okay, cryptocurrency uses blockchain technology. Yeah, that's right. So how old do you think blockchain technology is? How old? How long has been this technology around for? with us. I have lots of 10 to 15 years, 2008. Okay. I will discuss about this in detail in next slides. How long has it been around us? I'll discuss about that. And that we have identified using patents. I also want to know, you are starting, for example, you are starting a business and you want to apply blockchain in your business because lots of you are interested in blockchain. So maybe you are thinking, maybe use cryptocurrency, start a business based on cryptocurrency, or start a business based on blockchain. So what is your first point of source to begin with in terms of technology? Can anyone suggest me? If I want to start a business in blockchain, what should be my first point of source to begin with? I have an idea, for example. I want to make, for example, somebody said, Mr. Prakhar said, ma'am, blockchain is for technology for storing database. So for example, I want to create a technology that stores databases. So how do I start? Where do I start? How do I start making sense of all this technology? Can anyone answer this time? Because we are not just talking, this session is not only about technology, or we are not going to discuss about how to create a blockchain. I'm discussing about the applications of blockchain in your business. Okay, someone said online voting system can be applied using blockchain. Yeah, for example, I want to create an online voting system using blockchain. So how do I start? Where do I start? How do I start to understand about blockchain? Yes, Hyperledger. Yesterday, someone said about this. You can search here. That's good. That's good start. But if I'm not well versed with the technological background, I'm not, for example, I'm not from the computer software background of it, then what? Or I just want to know about what blockchain actually is, and how can I, is it actually useful for my system, or is it for my business? How can I start? And whether I have enough money or enough, investment, to invest into blockchain technology. How do I make all these decisions? Also, we have lots of concerns about it being, taking more energy in terms of, it has more concerns about climate and, everything. So how do I think about that? And especially in an ecosystem like India, how do I think of, starting a blockchain-based business with all these constraints around? Can anyone answer? Wikipedia, talking to someone who is expert. Yeah, Wikipedia is good for general knowledge. Yes, talking to someone who is expert. Yes, that's also a good approach. But how? Not everyone has approach to an expert right now. Everyone resorts to internet or Google or somewhere. So how do you begin there? I will connect this question with patent analysis later in this session. So I think we have had almost 10 minutes of break. So any more questions? Any last questions? So after that, I will begin the session. First, we used to define the use case. Like I said, if I want to start the voting system in blockchain, if I want to create a voting system based on blockchain, will that be a success in Indian ecosystem? How do I ensure the success of that venture in Indian ecosystem? Can you suggest some areas for which we can work and have patent? It's whole big world of ideas. You can work on your ideas. You can see the feasibility of your ideas and start working on those patents. and maybe see what fellow Indian companies, fellow Indian inventors are doing in terms of patents. You can search for that. So, okay, let's start with the session now. So now I will discuss a little bit about technology concepts that we have been talking a lot in the previous session, the previous 1 hour, about technology innovation, technology trajectory. What I have been talking, the whole title of this session is about technology trajectory. So what a technology trajectory is actually. So when we discuss about the innovation of a technology, when we discuss about any innovation for that matter, what we think is how it began, how it gained popularity, and then where it is now. So that's the whole curve of a technology, like its birth, its growth, its maturity, and maybe its decline later on. So a technology trajectory is a single branch of evolution. For example, what I mean by a single branch is like, for example, you have, for example, there is a term called spin-off technologies. What it means is when a particular innovation is designed or intended for some other use. And then once it is used in, for example, NASA started memory foam, memory foam that we use so much in our cushions or, tabletops or chairs or anywhere. It was first designed in NASA. And what their initial intention was for the memory foam was for their pilots to have a comfy seat all around because they had a long flight and everything. So that was one restricted approach of that invention, one restricted invention of that invention, intention of that invention. And then now we see memory foam in a whole different context, in our everyday context. So from this branch, this whole innovation spinned off to another branch of evolution. So here, for the pilot in NASA particular, they had one trajectory of that innovation, like how they started specific use case for their pilots, for their own ecosystem. But now it's used everywhere, like in every household, for cushions, for soft, in shoes or shoe soles, everywhere. So that's a whole different trajectory. So when a technology innovates, it has lots of application everywhere sometimes. So to understand one single branch of that evolution, of a particular evolution, is called technology trajectory, how it started, how it's going, and where it's going, or whether it's going at all, or whether it's declining. So there are terms called incremental innovation and radical innovation. So incremental is when it's step by step, a steady innovation is going on. And then sometimes a disruption occurs. That's when a radical innovation comes into play, like blockchain. And I will discuss later that how old is blockchain and how it was before. It's a little incremental, and then there comes the disruption of blockchain as we know today, more like a cryptocurrency. So that has been a radical. So there, the path of technology changes to another trajectory. So we see that we have another curve for trajectory, new trajectory emerges from that. So this is what a technology trajectory is. And from that, we also can understand something about technology life cycle. It has 5 stages. First, it is its inclination, its birth. And then we have the early adoption, like when it's when a technology is new. So a lot of people, lots of companies, Incremental especially, the old ones, or the major big ones, they are a little skeptical of adapting to that new disruption. And then they start easily adopting. The users start to accept that technology, like they start to understand the whole technological ecosystem. And then there is wide acceptance along the masses, along the companies, along the whole worldwide. And after a certain point, there may be a decline in the technology, maybe because other technology has taken over, maybe not more innovations are going on. And then maybe after a certain point of time, there is a certain change in this technology stage, where the same technology is being merged with another technology or being used for quite different areas. So then we see this whole life cycle going ahead again. So these are the basic 5 life cycle stages of technology innovation. So some of the technology parameters that I want to discuss in respect to patents is that during the inclination phase, I'm connecting the patent parameters with the life cycle phase, that when it's the beginning of your innovation, when you are just starting your innovation, maybe you have more patents, maybe you are filing more patents to secure your innovation. So at that stage, especially the radical innovation, at that stage, the patent filing is high. At that stage, you might be still writing the patent, still writing the ideas. So patent filing might be low, but the innovation is radical. The innovation is being, everywhere. So number of patent applications per applicants is high. R&D risk is high. But as soon as there is the early adoption of technology, as soon as there becomes the awareness about this technology, the patents become higher. The risk becomes low. And with the wider acceptance, it changes from radical to incremental then. And the patents are in a constant stage in maybe 100, 200, 300, like that. And then the risks become low. But then when you hit the decline stage of a technology, again, the process starts. The patents become low, the risk becomes high. And then at the new application area, again, new patents, new risks, new applications begin. So that's how I wanted to just share the whole ecosystem of patents and technology lifecycle, how they are connected, how you can understand the connectedness between these two. So now we have learned about what a patent is, how it looks, what the data of a patent is, and then we understand about trajectories, what the technology trajectory is. So now, how do we link these two? How do we analyze patents to identify these trajectories? How do we identify the beginning of and how, more importantly, how these patents and identifying trajectories, how are they good for our business? Or how are they good for me to, when I want to start a new venture? If I want to start a new venture, how can I leverage patent analysis and technology trajectories for my new business? What can I understand from that? So I'll be discussing about this. So to begin with, we have some patent indicators. Like I discussed the spin-off technologies, like for example, memory foam I already discussed, and also GPS. Can anybody tell me where GPS started, the technology? You can write in chat. GPS technology or the scratchless sunglasses, how they started, where they started actually, which use case they started on. It began with NASA actually. They have these inventions NASA did for their astronauts or for their teams, for their ecosystem, but then they just spin off to the local masses. And we see them everywhere. GPS is everywhere. And we never even hear the term NASA in respect to GPS. So that's what spin-off technology indicates, that the patent indicator. So when you invent a patent in a particular direction, and then you see patents spinning, patents sprouting off in all use cases, that's when you identify the spin-off. And these are some patent indicators. I think I'll not go into detail of these indicators because that will be too technical. So I'll just go through, like you have immediacy, like when you apply for the patent and when you are actually granted that patent, and when somebody else cites your patent, how much difference is there in the time period of the link? And then how many dependents, how many claims are there in your patent? A patent has a field after abstract that's called claims, that what your patent is claiming, what is the novelty of your patent. So they are numbered actually. So what is the number of those patents? And then examination, how much duration is for the examination, and which year are they applied, how many priorities, like I explained before, how many region that patent has been applied before? Are there any significant regions? Like if I see a patent in US database, are there priorities from Europe or Japan, or are they from the other regions, not holding much importance? And then we have corporate count, how many companies a patent is linked to, how many inventors are related to different companies, or are they companies, or are they institutions, or are they particular inventors? And something important is the citations. How many of you know what a citation is? Have you cited anything while you write your master thesis or bachelor dissertation? Did you write a bibliography at the end? Yes, Mansi says yes. Okay. Yes. So what is that? What is that bibliography? What are those references? I hope this session is not going too slow for you guys, or from where we gathered or collected our data. Yes. So you when you write a paper or when you write a thesis, you study other papers, you study other resources, you study some books, and then you collate all this information in a reference, right? So similarly, when you write a reference, you are citing that paper. For example, if you write a reference for a paper, that paper is cited by your dissertation. So that's what a citation means, that the information from that paper is being transferred to your paper or your research. So there is a flow of information from previous research to your research. And maybe when your research is cited further, there becomes a path of information flow. Citation means a quote from any resource. No, it does not mean a quote, and that's a whole another discussion, but it means you are referring to something, previous information, you're referring to previous information, something like that. So, okay. So similarly in patents, when you see a patent document, before I also showed you, there were citations of patents and papers. So a backward citation is, if I am writing a paper, if I am writing a patent, how many patents am I citing? So that's my backward citation. How many papers, how many patents, how much information am I citing in my patent? That means how much information, how much existing information I am, taking forward in my patent, in my information. And then forward citation is how many future studies cite my research. So how my research is going forward to other information flow. That's a forward citation. The patent analysis is actually when we discuss about the trajectories, when we do the patent analysis, the whole analysis ecosystem is based on the citations, because that's the indicator of how the knowledge is flowing from one patent to another, from one knowledge idea to another. Okay, I have a chat. The way you tell your readers that certain material in your study is citation, the way. Okay. Okay, the citation, okay, something about citation will be a whole different topic of discussion, so I'll not focus on this one now. And then there are IPC codes, which I already discussed, like they are the technology codes. For example, mobile wallet may have a code for semiconductor, may have a code for electronic payment system, related to electronics. So there might be different technology codes related to a particular patent. So we can also identify how many technologies a particular patent is involving in their prototype, involving in their ideas. So moving ahead. Okay, wait a second. So here is a little snapshot of when I searched for blockchain in my research in US patent database, and I exported in Excel. So this, I don't know if all of you can see clearly this whole snapshot, but here you can see the title, the patent type, application number, application date, abstract, claim, IPC, and then we have on the third one, I'll go one by one. So first one is title, application number, abstract, and everything. Companies, assignee, country, applicant address. So we have all this information. And then we have IPC codes, and we have agents. If you hired any agent for filing your patent, and the inventor names and everything. And then we have domestic references and foreign references. These are the citations that I was talking about. So these are like how many patents you cited, how many patents you referenced in your document, and whether they were from the same patent office or they were from another patent office. They are mentioned in this document. And then there are other references, which means whether you cite maybe some research paper or some article or something. And then we have patent family, like I explained in the first session, that when your patent is filed in one region and then you file that patent in another region, or the similar invention in another region, they are clubbed into one patent family. And the first patent published in different region becomes the priority of that whole patent family. So these are some jargons, these are some terms used with patent analysis landscaping. Any questions till now? Any questions? Okay, I'll move ahead. So based on this, now it's a little bit technical here, so I will just try to make you understand. So from here, this data, how do we make sense? How do we analyze this data? One thing is, there are lots of analysis methods, as I discussed before, but the major is the citation analysis. Because when we talk about citation, citation is basically the indicator of knowledge flow, how a knowledge is flowing from one to another. Like I am giving this session, I'm explaining something to you, you learn something from here. And then maybe when you go to your home or to your friends or somebody or in your business, and you want to discuss this with someone else, and you say something that you learned here, maybe about patents, maybe about patent analysis, you are carrying forward this knowledge. I am carrying forward this knowledge from what I have learned from my mentors, from where I have learned about all these things. So the knowledge is moving ahead and it's creating a path. So maybe someone started this discussion and then it carried forward. Now from here, you will carry forward this discussion. So there is a path going on. So there is a citation also going on. Like if I'm saying this, I might say that maybe I really enjoyed the MIT open courseware for blockchain technology by Gary Lesner. You can search it on YouTube. So maybe from there, I'm citing him. I'm citing that session here in my lecture. And then when you are going ahead or explaining something to someone else about patents or blockchain or something, maybe you'll say that you learned something from this session, or you heard about MIT courseware as a YouTube channel, and then you cite them also. So there is a link that is created, about whole knowledge ecosystem. So that's the concept that we include in patent analysis. That's the concept that we try to analyze and identify. And from that, we try to identify how technology started and how its path is going, like a trajectory. What are the initial innovations, and how are the latest innovation, and how do we find that? How do we find the path? And that is through the citations. From the citations, because we know a technology was created, and then somebody cited that technology, some other patent cited that technology patent, and then someone else cited that patent, maybe 100 others cited that patent. So the whole citation link is created through the whole technology innovation path is created through the citations. So how do we do that actually? So I'll just give a snapshot of basic information. I have a Mansi is saying, I know it's a different topic, but can you please guide what point should we consider? It's a totally different topic, Mansi. Maybe we'll try to have someday another session on this, because it's totally different, not here, not in the scope of this. Maybe at the end we can discuss. Just save this question for the end. So moving ahead, So the first thing in citation analysis is creating a citation matrix. So whenever, I don't know how many of you are familiar with neural networks also. So an input in a neural network is usually a matrix. If it's a structured analysis, if it's a non-structured, it might be a text mining concept or something. But when it comes to the structured, or maybe what is it called? Supervised learning, when it's called, then we talk about, then we have input is the matrix, where you have some certain attributes given to the matrix, and you tell them that, okay, this is the certain attribute, this is the output that it should link to. So similarly in here, the citation, we create a citation matrix. What a citation matrix is, it is the relationship between different patents or different technologies, and we create how many citations are occurring between all these technologies or patents. And for example here, and this matrix is a square matrix. If you all know the square matrix, if we it's an m by m or I by I or n by n, like rows and columns are the same number, 5 by 5. For example, here we have 5 by 5 matrix. So X32 denotes that a technology T2 is citing technology T3, right? So that's what the cell in this matrix denotes. I'm just giving a brief about this whole. So now here, how do we make sense of this matrix? How do we understand about this matrix? What can we understand by the numbers? I will also show you a snapshot of the matrix that I created. So, but here, A, B, C, D, E, F might denote a technology. How do you denote a technology in patent analysis data? By IPC codes that I mentioned. And it can be patent numbers if you want to just go through the innovation, like you want to just see which patents are citing which patent. So you just make a matrix for patent numbers, or you can make a patent for a matrix for IPC codes. And then you can also maybe make a matrix for companies. Which companies are citing which companies? How do you identify which company is citing which company? By their patents. Like if a patent has, for example, the patent snapshot of mobile wallet was from Microsoft. Maybe that patent is citing another patent from IBM. So there is a relation between Microsoft and IBM. For example, if A is Microsoft, B is IBM, we have a relationship here between A and B. So we can say one citation or two citation or how many there are. So in here, the rows are the citing patents that A is citing, B, A is citing, sorry, here A is citing D, E, and F. That is like, just like the bibliography in the end you write in your thesis. If I am A and I am citing D, E, F, that means I am incorporating some part of their innovation in my innovation. So that's why I'm called knowledge absorber or technology innovation absorber, because I am absorbing from the previous knowledge. That's how you can understand a reference also, that it is not just a quote about previous knowledge, but you are taking the previous knowledge and applying it to your own innovation somehow. So you become the knowledge absorber. And then the ones that are cited, for example, F has the maximum number of citations here, like A is citing F, B is also citing F, D and E are also citing F. So it has lots of citations. That means it has something to provide to lots of other companies or patents or technologies. So it becomes the knowledge provider. And when we see that first box has no citation, that means the innovation is going on parallel. Maybe they're not connected or something. Then we have one citation from C to D, we have one, but D to C is no citation. So that becomes sequential. But when we have a two-way citation or two-way information exchange, the innovation becomes coupled. So these are some terms that are related with patent analysis I wanted to share with you, just to make sense of what a matrix is, what this matrix denotes actually. So moving on, and then this is also when two technologies, two innovations are citing each other, are coming together, maybe they are converging together because two different technologies are citing each other. So there comes a conversion. So you can identify how different technologies are converging. There is a study on convergence of information technology and biotechnology, convergent cluster. So they also identify the future of the convergent cluster, and they identify some citations, and they project the future of these technologies. So you can identify different convergent or maybe diffusion clusters from this whole citation matrix. Any question by now? Okay, Mansi has said, yeah, we'll take this question in the end. Any questions? Okay, I'll go further. So from this citation matrix, what we form is a network. How? Here we see that, I don't know, how many of you have heard about the graph theory or the shortest distance, shortest path method, shortest distance method? Any BTech guys, or maybe in operations you heard about this? You identify it in the transportation problem, maybe finding the shortest path in the whole network, or from different routes you find the shortest path. You make a different route, and you chart different routes, you chart different using AI. Alok says using AI. Okay, Mr. Alok. Okay. In AI, wow, you use shortest path in AI. So yeah, in next slide, this is just a diagram of network which is created from this citation matrix. How is it created is, this is just an example. If you want to create from this matrix, there will be a node A. From A, there is a path to D, E, and F. From B, there is a path to F. From C, there is a path to D, D to F, like that. So that's how you create like that. So in this diagram, you see there are some nodes, and then there are some paths from A to C, and then B to C, and then C to E and J, like that. So when you have a bird's eye view on this network, you see at the beginning are only two nodes, A and B, and at the end are three nodes, H, J, and I, and in intermediate, and there are some intermediate nodes. So these the ones in the beginning are called source nodes, and ones in the ending are called sink nodes. In terms of technology, what you can identify from this network is what's the beginning innovation in a particular path. What was the beginning innovation? This can be a patent, this can be a company, this can be a technology, whatever you are searching for. So if I am analyzing patent documents specifically, so A and B will be the first patents, the initial patents, initial significant patents that have been used widely in the technology evolution or in the technology innovation path, that have been widely used in the further innovation. So for example, A and B are both used by C, and then C is used by E and J. So like that. And then how this innovation has created further, and where it's at now. So now it is at H, J, and I. So from here, I can see maybe A is about for example, A is the mobile wallet payment, for example. Let's just think about that. The mobile wallet payment, because I showed you the snapshot, so you can picturize it. So let's just think of A as that patent. And then C is citing that patent. And then, for example, J is some patent. Maybe you search on the database, identify some patent, and J is that one. So the innovation here of mobile wallet begin with A, with the Microsoft patent. And then now maybe J is an IBM patent, or maybe some startup patent. So now it's at J. So the starter of this innovation was Microsoft. And then now it's moving ahead to some other company. Now another companies are absorbing that knowledge from Microsoft in their whole path. So that's the whole idea behind this network that is created from this citation matrix. So I will discuss this whole network that I created for blockchain technology, and then we'll be able to add the application part into this. This is right now, it's just technical specifications of this whole network system of analysis system. So for example, here is, although this is just a snapshot, when I searched for blockchain patents, there were around more than 10,000 patents. And then when I created the matrix, and in the matrix, I only consider those who are cited at least once. So here you can see lots of zeros, but the total citation count that I got from this whole matrix was around 5,369. So that many citations were there in the matrix. So on the row header and column header are patent numbers. So if I want to, for example, here, the first patent, here you see lots of zeros, but maybe here is a 1 somewhere. So that means that patent has relationship with another patent that cites another patent. So this is just a snapshot. And then initial, the first. Okay, do we have any questions right now, till now? So okay, let me just say about this one. So from the first adjacent matrix, I have this matrix was 6201 by 6201 matrix. That is 6201 rows and 6201 columns in this matrix with 5,369 citations. So when I want to create a network with so many nodes, like here in here is just 5 or 6 nodes. It's easy to understand. It's easy to even do by hand. But when you have data with 10,000 nodes or more than 1,000 nodes, this is what you get. This is the diagram that you get at the first point. So how do you make sense of it? How do you identify the clusters? How do you identify the prominent path of technology innovation? Can anybody suggest? Anyone can anyone suggest? How do I, from here, I want to go here, like this simplified path. I want to identify the simplest path that shows me the significant innovations in this whole network. Can anyone guess or just suggest? Anyone? Somebody has raised a hand. We can select some from them as sample. Okay, some, like a random sample. No, we cannot do it on random because we are trying to identify significant innovations, right? Yes, shortest path algorithm. Yeah, because I just said about something about shortest path, you know. So that was the hint actually. Yes, we use the shortest path method. Yeah, we can use data analysis too. But what algo do these tools use? So yeah, shortest path or the path with the highest weights. In this term, in patent analysis jargon or patent analysis ecosystem, we don't use the shortest path. We use the path with maximum weights. That is the innovations that have been traversed a lot, because those are the innovation everybody is going through. Maybe a patent is cited by 100 patents. And then those 100 patents are cited by maybe only 50 patents. And then they are cited by more patents. So when you traverse through the path, maybe a particular patent is being traversed again and again in that path. So that has the more weights. So we identify the more weighted path and we call it SPLC. So search path link count. So it's based on how many links a particular node has. So the one with the highest node, the links with highest nodes, highest weights are considered for the final network. Just like the shortest path, such as you find in the shortest path, here you find the most weighted path. Like here, if you say there are numbers, so the one with the highest number count will go into the final network. So here, from here, we arrive here, right? And even in this one, we find the most significant path with the dark arrows. And there is, it's not like that you just get the one path. You might get some different paths, not connected to each other. Maybe you might get 3 clusters or 4 clusters or maybe 10 clusters. It depends on your how many clusters you want to see. And then you can find different networks of these paths. And how do you make sense of these paths? What does this path mean? So for example, here, we have new energy vehicle path diagram. So here are 3 paths: path A, path B, and path C. So one is the market influence research innovation of new energy vehicles, which is the path A. And then path B is for the subsidies, and path C is for the charging station. One technology domain, but 3 subdomains, right? So you can, if, for example, now you are trying to penetrate the market of new energy vehicle, for example, now because electronics, e-vehicles, autonomous vehicles are a lot in the talks. So maybe you want to try to go into that segment, but what particular domain of that technology you want to focus on? Do you want to focus on charging station of those of the e-vehicles, or do you want to just penetrate you want to create new e-vehicles or energy vehicles, or you want to be in the subsidies area? So from here you can actually identify which path has the more dominance, or which you can identify the weak links also. Like some path may have lots of innovation, and some path may be just emerging. So you can penetrate that one, and then you can try to be a market leader or in that, or something like that. So that's how you decide from this network. Any questions till now? Any questions? No? Okay. So now let's identify some trajectories. I'll go with an example of blockchain. And then do we have any questions I can take some questions for 2 or 3 minutes before beginning. You can raise your hands if you want to talk, or you can just write in your chat box. Any questions? Or do you guys want a break for 2 minutes? Just let me know. Somebody says yes. Yes for the break, or yes for the question. You guys want, can you please sum up last slide? Okay, this one? Okay, yes for the break, okay. Okay. Yeah, I will discuss this last slide more, discuss the more application of this last slide in the practical example in the coming session, where I discuss about the blockchain paths. So that will give you a more clarity. This is just for the background information. Okay, so fine, we can take 5 minutes break. 5 minutes is, I think, let's take 5 minutes break and come here after 5 minutes. And come back with questions. I want to see more questions. In the next session, I'm going to ask some questions. So yeah, okay, let's have 5 minutes break. So is everybody back? Let me know if I can start the session. Okay, I have one yes. Okay, good. Okay, so do we have any? Okay, let's just begin with the application. Let's just begin with use case of identifying some trajectory, and I will start with a blockchain example. But first, now I want to ask you all, like I asked also before, that what's the difference? Is blockchain, how old is blockchain? How old you think how many years blockchain have been with us? So before I have received answer 2008, 10 years, 8 years. So are there any more answers? Although first Bitcoin 10 years. Okay, 10 years means 2012. We are in 2022. So 10 year, maybe 2012. Oh, sorry. Yeah, 12. Okay. And what was the first transaction based on blockchain or cryptocurrency? Anybody? Does anyone know about the first transaction based on the cryptocurrency? It was a transaction in 2010, and somebody bought a pizza based on Bitcoin. And that time, few Bitcoin was worth the price of pizza. And now everybody knows what a Bitcoin is worth. So any more answers apart from 10 year, 2008, 2009? No, are all participants here? Okay, so I would say maybe you look after later on Google or anywhere, the longest running blockchain is from 1990. The first blockchain application was in 1990. So what we know today is the cryptocurrency aspect of blockchain. That's what made blockchain famous in the market. But it has been there since 1990. And Stuart Haber was the first inventor of blockchain, of that application. And it was not a cryptocurrency. It was just a chain of blocks. And you can, if you want to read, you can read a New York Times the blockchain appeared in New York Times newspaper. The numbers, they used to update their chains, and they used to publish those numbers in New York Times. So that has been the longest running blockchain since 1990s. So it is not a new application. But when you think of a blockchain, you only think in terms of cryptocurrency, right? You only think in terms of Bitcoin, Ethereum, or now the Dogecoin, which Elon Musk tweeted about. So, and now I also saw the examples of voting system, storing databases. But how do you identify the trajectory of blockchain? Now that I have told you that it has been in the market since 1990. So what comes to your mind after getting this information? What do you think about it? Can anyone answer just quickly? Okay, so if nobody is answering, I'll just move forward. So 1990 to 2008 was just the blockchain hash functions related to the blockchain. And it was by Stuart Haber and Scott Stornetta. And they were very famous for their New York Times blockchain numbers. And 2008 came which was the first Bitcoin in production by Satoshi Nakamoto in his paper 8 and 9. So that's when cryptocurrency became popular, and that's when blockchain became popular. And when I think till 3 or 5 years back, I think we would have, exchanged blockchain with Bitcoin in terms of nomenclature. We would have, confused blockchain with Bitcoin. If somebody said blockchain, we'd have thought, okay, Bitcoin maybe, or Ethereum maybe. We could not think of the possible another scenarios based on blockchain. So till 2014, or even now, the major application of blockchain, what is the major application of blockchain? Major domain or major sector in which blockchain operates? Can anybody answer? Do we have all participants? Can anyone answer? No? So that's the payment sector, fintech sector, financial technology sector. That's where the major applications of blockchain are concentrated, apart from cryptocurrency aspect, because it removes the need of intermediary in the transaction process. So that's why in the financial technology sector, blockchain is still dominant in terms of its application in other areas as well. So in 2014, we get Ethereum, smart contracts, proof of work, and that's how we move ahead from Bitcoin and we move towards Ethereum. And then onward and upwards, the blockchain has found its application everywhere. Now that we have voting systems, we have so many different applications that I will discuss later in this session. And before I go ahead, I want to show that I will identify some clusters based on patent analysis in this session. I have identified and I will discuss it with you. And then later on in the next session after lunch, you will get the business point of view. You will get to know how to use that information in your businesses. If you, for example, we are taking the case of blockchain in here, you can use any technology. You can use any technology analysis and then try to identify how to use that information in your business, how to identify competitors, how to identify your niche based on the patent analysis. So I'll begin. So nobody has anything to give or ask in this right now in terms of blockchain? Okay, so before starting, for my patent search, as I told you earlier, that you have to be very specific with your search strategy. You have to identify your search terms. You have to identify your search nomenclature. So it is also a different field of research work or analysis work to be done. So you cannot just search blockchain or Bitcoin and then just go about the analysis work. No, because Bitcoin is just one part of blockchain, one use case of blockchain. Ethereum is one use case of blockchain. Proof of work is the concept behind Ethereum, behind the concept behind this blockchain. Then there are some more Namecoin, Litecoin, the different versions of blockchain, cryptocurrency more importantly. And then there are processes, that is the decentralized ledger, the distributed ledger, distributed databases. And then there is cryptocurrency. Cryptocurrency is strictly related to blockchain. So we have to identify these keywords. And you can use scientific processes, you can use cytometric analysis, you can skim through reports, you can skim through the technology reports of many major companies like McKinsey or Accenture or IBM for that matter. They have a very comprehensive technology reports that sometimes they provide these terms based on a particular technology. You can go to patent databases and see their innovation landscape reports and identify the terms and just see how your results change when you change the search terms and search results. And then there are IPC codes. Like I said before, when I searched for blockchain, I also got the results for cement and polymer and so on, and the likes of it. So how do I, narrow down my search? How do I narrow down my scope of, like, I want blockchain in terms of cryptocurrency, in terms of technology, not the polymer science blockchain, not anything related to chemistry or anything. But then I cannot remove I cannot say that I do not want patents from chemistry background, but because there may be some application in saving chemical codes based on blockchain structure, maybe chemical information based on blockchain structure. Now everything is interconnected. So we skim through the IPC codes that this technology is based upon. So we get these 5 major codes, that H04L, G06F, 9C, H04M, data processing for G06Q. It's on your screen. You can go through it. And these are the 5 dominant clusters that you identify. So this is this search strategy that I developed was based on scientometric methods. I did some scientometric analysis. You can also do text mining on patent data or research articles based on blockchain and identify some important keywords. And one thing important here is businesses do not need to do this, because this whole workshop, this whole conference is for the new businesses. But why you do not have to spend your time in this whole analysis part. You can use third party to do this. And I want to add here that in India, maybe not many companies or not many third parties are doing this type of research or providing this type of solution. But IBM, you can search for IBM Watson. It's a patent analytic tool they have come up with, where they do all this that we have been discussing since morning. They have their own sector, but they have their own analytical unit for that, IBM. And then we also have all these USPTO, all these patent databases. They are also providing some sort of paid services. And then many countries have these small startups coming up to do these services for you, for the startups or for the incumbents alike, because everybody wants to know what their competitors are up to. Because when you file a patent, it's the beginning of your innovation. You might be coming up with some technology after filing your patent. You might, like I gave the example of Apple iPod. So if I wrote a patent on, for example, smart contract. I'm just giving an example. I did not write that. But for example, I write a patent on smart contracts. And nowhere in the patent is the term blockchain mentioned. But when another company or my competitor, they are well versed with the concept of blockchain, so they search this thing and they see that their competitor is doing something in smart contracts. I have Pratiksha Sharma raising hand. Okay, I will allow you to talk. You can unmute. Pratiksha Sharma. Are you going to ask something? Hello, Pratiksha. I think it's by mistake. Okay. So I'll take only questions from the chat from now on, and in the end, if you want to raise your hands. So anyway, where was I? Yeah. So for example, I write something on smart contracts, and my competitor finds out or analyzes the patents and finds out, oh, their competitor, that is I, am doing something on smart contracts. So they try to predict what I'm up to. So they see all my patents related to smart contract or something related to proof of work if I have something, and they can predict that what I'm coming up with, so that they can create their innovation strategy based on this. Like maybe they are also working on something similar, but they don't have the patents yet. And by seeing my patents, they will understand that, okay, she's coming with this particular product maybe, or solution maybe. So how do we change our strategy? How do we penetrate the market or be better in their services? So that's a whole lot of decision making you can do based on the patent analysis, based on the knowledge of patent. But you do not need to, if you alone, like if you as an entrepreneur or a starting business spend so much time on analyzing patent trajectories, innovation trajectories, you won't have time to actually work on your patents or your innovation or your startup or something. So all these things are done by experts usually. So moving on, so we have to identify the particular keywords, particular technologies for creating a good search strategy. So moving forward, this is the result that I told you before, that I received more than 10,000 patents. And I told you before that first you apply for a patent, and then it is granted and published. But in between the process, your patent is also available online. I mean, not free of cost, but on the database, it's available for other innovators to cite or to use. So you can also distinguish between the trend of applied and published patents from here. And then we do a simple family merge. I told you about the patent family, that when many similar innovations are, when a single innovation is applied in different offices. So getting the same innovation in my data will just give a duplicate with different office only. Just the office and patent number may be different, but the innovation is same, the title is same, the whole inside metadata is same. So we merge these data and we merge these families together, and we get the data together. So like I showed you in my snapshot of data set, at the end column, we had a column for patent family that gave all the patent numbers for that one particular patent, their priorities. So from 10,000, we skim down to 6206 patents. And from these 6206 patents, we create 6206 by 6206 matrix. So these are the fields that are obtained in the data. I also showed you the Excel snapshot of this thing. So moving on, this is for the blockchain, the search strategy that I showed you before here. So this is the trend of published and applied patents. So we can see that the first patent we have is from 1974. And then we have, that is published patent, and then applied patent. And then we have 1976, one or two patents till 1990. And then we have 1988 has 5 patents, but all these are not strictly related to the blockchain we know today. These are based on the background technologies of blockchain. But blockchain is actually comprised of, because since blockchain has been around us since 1990, but cryptocurrency is only since 2008. So before that, what was there? Hash functions, digital signatures, maybe. So those are the patents that they are concentrated upon. So here and then you can see, after 2008, there is just a rise, and then 2015, you can just see going exponentially up, the application and the publication both. So one thing that is important is, though 2008 was the time when we came to know about Bitcoin, but almost after 10 years, almost after 8 to 10 years, we see the rise in its acceptance in the wide. It became famous more after 2015 or 16. So there was a time of early stage of Bitcoin where nobody was sure what it is, what's going on in this technology, how it's because incumbents were so much confused. I mean, they didn't want it to apply this technology, and startups were just disrupting the whole market. That's why it was called the disruptive technology of the decade. So then when the big companies started to acknowledge this technology, started to accept the applicability of this technology, is when you see patent also rising. And even if you search for research papers based on blockchain, you will see lots of papers since 2015. But before that, it's just maybe a few, 5 or 6 or 10 or something. So moving on, and then we can also identify the number of patents based on each technology cluster, like transmission. And now here is what you can understand is what's the base of this technology in terms of technological codes, in terms of technological groups. Like the first thing is transmission of digital information, that is the H04L, because like we had discussed before also, It's the like storage of database, storing or voting system or healthcare patient record system, or so it's a chain of blocks where the information is stored. So that's why we also have the transmission of digital information code with the highest number of patents, with more than 2,000 patents, 2,500 patents. And then there is electric digital data processing, because it's a technology based, and it takes a lot of electrical energy in terms of computing speed and everything. And then we have data processing. And interestingly, we have a pictorial communication. So can anyone give me an example where in pictorial communication blockchain can be applied? IPS, yeah. Anything else? How in MIPS do you think it can be MIPC? Okay. How does it apply in MIPC? Can you elaborate, Mr. Samir? And then we also have wireless communication networks, because yes, now most of the technologies work on wireless communication networks, so we can relate to that. So moving on, then we can also identify which patents are cited the highest. So that also tells the the weight of the patent, weight of that innovation. That what importance does that patent have in this whole ecosystem? Let me tell you that a citation matrix gives us the significant path network where some significant innovations are traversed back and forth. And this one, where we identify the highest citation, this can only show us the patents that are more, they can serve as the base of the technology innovation. They can serve as, or maybe the hot patents that we can say, okay, yeah, this patent did something that everybody wants to use it as. So we have some companies or inventors, and then we have titles and US patent. The first is the method and system for storage and retrieval in blockchain blocks. So yeah, storage and retrieval. We have smart devices and data analytics. And then we have, counting votes in an election. And we have got 108 citations for this patent. This is by BlockTech. It was a startup at that time. And so this means that voting system based on blockchain can be a higher candidate for innovation. And then we have cryptographic currency, and then something related to the cryptocurrency part of it. And then we have identity verification, and so on and so forth. So from looking at this whole map of highest citations into the patents of blockchain technology, we just get to know how many companies are citing these patents. Out of 221 citations that it has got from 30 companies, the first one, and so on and so forth. So many companies are doing some innovation and patent. Maybe one company is filing 5 patents and based on blockchain and citing this particular document for 5 times. So we have this information based on that. And moving on, since this slide, this was based on the number of patents that are cited, highly cited. And now we move on to the companies. Highly cited patents and highly cited companies, these are two different things. How? Because IBM may have 200 patents, for example, and those 200 patents may be cited. One patent may be cited 10 times, another maybe 5 times, another maybe not even 1 time, 0 times, another 1 time. So all these accumulation of citation makes to the citation of companies. And for example, here we see IBM has 246 patents, and then the citations to these 246 patents are 278. And the self-citation, what is a self-citation? when you cite your own patent or your own document, like for example, if I am working on something and I have published more than one document on the same research or maybe I have published more patents on the similar innovations or similar technology domain. So I want to cite my earlier because I am, gradually promoting, or I'm gradually improving my work. So I am citing my previous work also. So those are self-citations. So IBM company has 57 self-citation and the inventors are 432. You can just create a picture of all this data in your head, or you can just visualize this whole data based on your interest, and you can see which companies are doing what in terms of the numbers. This is just a number, like how many patents does IBM have in terms of blockchain, of course. How many patents does Alibaba have, or how many patents does A&T have, and so on. And what are the citations that they are going through? How many citations are they getting from another patents? So one important aspect that you can understand from this whole company information is you can identify the roles and positions of these companies. Like a company with highest patents and highest citation may be a leader in that innovation, or a company might have a lot of patents but not many citations, or a lot many citations but not many patents. So that's the whole analysis, whole assessing that you can do to identify the roles and positions of those companies in the technology innovation ecosystem. So here we can see that Alibaba and IBM are the leaders in this. The arrows denote the citation relationship between these companies. Like they have more self-citation, but others are also citing them, and they are citing some. So we created a matrix for company. And before, like I have shown you before, was the matrix for patents. Here it is for the companies, like which company is citing which company. So here you can create a relationship from the company. So here you do not create a network with the shortest path. You just create a role and position map. So which one is at the leader point, which one is significantly emerging, which maybe there may be some company which nobody else is citing, but it is citing everyone. So it is just a follower, not still into the leader or significant emergence domain. And some maybe the leader is also following that particular company, and then some other is also following that particular company. So they are kind of emerging into this domain. And then we also have non-practicing entity. In this result, we don't find any company into this circle, which means that it's not following too many, it's not citing too many documents, maybe just one or few from the leader domain, and then that's just it. Nobody is citing it. It's not even citing itself. Maybe it has one or two citations, something like that. So we can identify hold the leader follower dynamic between the companies through this citation analysis also. So it is a little bit statistical if I want to go into deep, but I'm just trying to give you a snapshot of how you can identify. It's just a basic thing I'm showing here. You can also create some weights based on weighted matrix or something like that. Do for your further research or something. And then this is for the company. And then based on my results here, based on these results, I created the matrix for 6206 patents. I created the adjacent matrix. And now I want to create the network. Like I said before, with the most weighted network. And I tried to, although my network was very cluttered in the beginning, and then I tried to identify 4 or 5 clusters from that network. So I received 5 clusters. And when I studied these clusters, like I just go through these clusters, 1 and then 2, 3, 4, and 5, all these clusters. So what does this mean? How do I make sense of this cluster? So I just go through the patents in this cluster. Here you can see the number is first, the information on the nodes is the year, and then patent number, the technology code, and company. Why I have written this is because here tells us the obviously the application or publication of the patent, and then we have a unique patent code, and then we have technology code, and then we have company name. So it's upon you how you want to analyze this network, whether you want to analyze based on the patents, based on the technology innovation, or you want to analyze based on the technology codes or technology domain, or you want to find out the company position, find out how companies are citing each other. So you can do many things with just one network, with just one a citation matrix. So it's upon you how you want to tweak this data. Maybe you can come up with some other information. You can suggest some more analysis parameters rather than patent, technology, and company. So I love to get the more suggestions on this. So my 5 clusters, when I study these clusters, when I study these patents, and here you see, like I told before, the source and sync nodes. So we have lots of source nodes, lots of sync nodes, and then we have different paths emerging here, like first path and then second path, and then the downward path has in between there are nodes that are being cited by 2 or more nodes. So here you can identify the important innovation, the significant innovations, or the ones that have been used by many, maybe just for the base of the technology, maybe just for the understanding, or maybe there are some significant innovations in that particular field. So here, one thing that is interesting, that this first cluster is based on digital signature and ownership. When I studied this, how do I come up with this term is when I try to identify these patents, I try to study these patents from my data set, I find out this cluster is more focused on digital signature and ownership. And this is the oldest cluster, like it traces back to 1990s and then to the latest 2021 or 2020. And in this cluster, you see I'll show here. You see this whole lots of patents, lots of documents being cited. The arrow indicates the flow of knowledge from one patent to another. So this patent's knowledge is being flown here. So more than one document is using this patent, and you might be able to see Silvio Micali in here. So I would like to add to this that Silvio Micali is known as one of the most active researchers, active patent innovators in this blockchain field. You can just search about him. He also has come up with his company now with decentralized apps or something. So he's also working on decentralizing the blockchain domain. That is, how can we use blockchain without decentralization? So currently he's working on that. So you can see that based on his current patents. But he has been active since 1990s in terms of blockchain application, in terms of background of blockchain applications. So that's how you identify prominent researchers, prominent innovators. Or also here, we also see a university coming up, Stanford University, Stanford Junior University. And you can identify that maybe they have something important to give us in terms of knowledge, in terms of innovation. So the first cluster, this focused on the digital signature and ownership, and you can just do a lot of things with this data. So then second cluster is for data allocation and authentication. And third cluster is computer software verification system. And fourth is decentralized transaction methods. And then the fifth cluster that we retrieved is based on the blockchain-based networked infrastructure, the big infrastructures. That's the current cluster. That's the latest clusters, latest innovations that are going on. That how to use blockchain in a big ecosystem, in a big company, maybe in a network company. Maybe if I have a company in India and in US or Taiwan, so how do I connect the data between these three companies using blockchain? Or how do I, not just data, how do I connect the processes, the operations using blockchain? So that's that's where blockchain is going now. So Yeah, so in the first cluster is public key cryptographic methods. That's the base of blockchain, cryptocurrency and digital signature. That's how you identify scientifically what's the base of a particular technology. And then 2000 onwards, we have distributed digital signatures. With the introduction of Bitcoin, more patents came up with distributed and decentralized methods. And then 2010 onwards, we have signed video streams, like the pictorial communication example is signed video stream, video games or video game payment system based on Bitcoin or blockchain, and DOI or digital object verification like that. And the second cluster is data allocation and authentication. It's more in terms of, it started in terms of financial transactions with Visa International and Siemens and Sun Microsystems. So all these nodes are source nodes that from where it started, from which innovations were the base of this cluster. So we have Sun Microsystem is Adobe now, I think. And then now it has, I mean, merged to Amazon and SAP and so on. So you can, when you go through these patents, you identify that these are based on real-time data authentication, taxation referral, privacy preserving authentication, and so on and so forth. So this cluster is more focused on transaction, more focused on digital certificate of transactions. So what these clusters are is that, like in the first slide, when I talk about technology trajectory, is that it is one path of a particular technology innovation, one single stream of innovation. So when we talk about blockchain, it's not just the Bitcoin, it's also digital signature, digital data allocation and authentication. And now the third cluster is computer software verification system. So it starts with HP, IBM, and Sun Microsystem with source nodes, and it goes towards university is at the sync at 2018 patent of Northwestern University. We have Factum at 2017. So this is how the trajectory of computer software verification system in terms of blockchain technology. That's one stream of innovation of blockchain technology in terms of computer software verification system. So if your business wants to if you want to do a business related to computer software verification system or software integrity or distributed software verification system, something like that, you can identify the patents in this trajectory. You can identify the companies in this trajectory, or you can do more analysis, so identify more keywords or more patents based on that, and then decide where you are in this whole innovation system. And so moving on, we have fourth cluster is when decentralization came into place, because now it's more like decentralization and distributed methods. So in here we have IBM at the source from 1999 and 2001 patents. And then at the sync are the startups like blockchain tech, R3. These were all new entrants at that time. And at the base is the incumbent, the basic technology, the big names, IBM, like that. And this is where the proof of work also, interestingly, proof of work was introduced in 1990. So when you think about blockchain in 1990, that's when proof of work also came. So it was just made famous with the use of Bitcoin. And since 2010, it has been smart contracts, proof of stake, and distributed systems, decentralized databases, and things like that. And cluster 5 is for network infrastructure, as I told you before also. So all these patents talk about the user authentication, database management, record management in terms of enterprise level decentralized systems, or cold emailing based on blockchain through network, or data security for that matter. So all these A&T had the most advanced new technology. This is one of the most prominent companies coming up in the role and position interface of the analysis of this patent, of this blockchain innovation. And then we also have some IBM, MasterCard, and like that, and then Turing Technology, like that. So big companies are working on this. So that's how you can identify that since they're working on this, maybe you can provide, if you want to provide a solution for blockchain technology, you can provide something based on big, large infrastructure level. You can not just database storage, because that's everybody is doing that. Maybe try something at what can be done at an enterprise level. How maybe HR systems, maybe operations, supply chain. Supply chain is also very famous blockchain application studied and being studied right now. So you can do that based on by identifying these clusters and structures. So now, how do I map these whole clusters into one trajectory, one evolution trajectory of blockchain? So here we can see, as I mentioned before, 1990 is when the emerging innovations of blockchain occurred with public key cryptography, digital data streams, digital signatures, and then 2000s were the software verification, distributed systems. 2010 came with Bitcoin, was distributed transaction, proof of work, smart contracts. And then 2015 saw the application of blockchain moving away from cryptocurrency and into all sectors, into Industry 4.0. Industry 4.0 means IoT, big data, cloud computing, everywhere. Everywhere we could see the discussion of blockchain going on. And that's why after 2015, we have lots of patents, lots of papers, lots of magazines, reports based on blockchain and its application everywhere. And now 2020, 2022, we have blockchain applications based on enterprise level or large infrastructure, as I discussed before. So one interesting thing you see here is that the early period, the innovation gap is of 10 years, like 1990 to 2000, 2000 to 2010. It's a 10-year gap, whole decade gap. And then from 2010, it's just narrowed down to 5 years, just half, 5 years, 2010 to 15, 15 to 20. And maybe in the future, it's just 3 years or maybe 2 years or 1 year, or who knows. So the gap is going narrower. The innovations are spreading a lot and the gap is going, the evolution gap is going narrower. Or maybe it's just the beginning of this technology. It's just the beginning of wide acceptance of this technology, as we discussed in the life cycle, technology life cycle curve. Maybe it's at the wider acceptance. And after maybe for next few years, next 10, 20 years, we have blockchain-based infrastructures. We see blockchain just as we see IoT now everywhere. So maybe after that, the curve declines, or maybe we will find some new innovations. So based on patent analysis, we can also project that future. We can also, based on the citation matrix, we can also project the future citations, future innovations. But that's all predictive. That's not a concrete prediction, but that's just to get the know-how of where it will be projected in future. So two things come up after this is, one thing is blockchain application in the sectors, and another thing is blockchain application in technologies. So here are some sectors where blockchain finds prominence in the whole patent domain, or even you might be seeing this in research or in talks or in articles somewhere. Fintech was the first application of widespread blockchain acceptance. And then was supply chain management. Operations received huge research on blockchain applications. So you might even find some startups or companies doing some business in this sector. And then there is energy sector, like new energy vehicles. I showed the path about that before. And then healthcare. Healthcare has been since 2 years. Healthcare application of blockchain, IoT, quantum computing, everything is being concentrated upon healthcare because of this whole pandemic situation. And how can we come upon faster solutions, faster vaccines or something in healthcare domain based on these new technologies, disruptive technologies, and even governments. I would like to add here that Indian Gujarat University, I think, Gujarat University or Gujarat University. It started its first blockchain-based degree distribution system, university degree distribution. So it's blockchain-based. And recently, I think last month they announced this one. And Dubai government is trying to be blockchain-based. Their operations, they are trying to make their operation based on blockchain. Before it was by 2020, but I think due to the pandemic, this might have been delayed because I don't see it in the news or something. So Dubai government is planning to become blockchain operated, their whole functions blockchain operated. And then US has lately a lot of discussion about blockchain and Bitcoin. Their Congress is doing lots of discussions. Then we have retail and consumer and entertainment media like video gaming. Video gaming has seen lots of blockchain, Bitcoin, especially cryptocurrency applications in blockchain sector. So this is the snapshot of sector, and then we move ahead to the technology application. So blockchain is if we think of blockchain alone, we might only be able to think about cryptocurrency, about hash functions or digital signatures. But when we have to think of blockchain application in different sectors, we have to think of it in combination of different technologies, because no technology is discrete now. All of them are connected. IoT, cloud computing, big data, everything is connected. And that's why we call this combination as Industry 4.0. And now even quantum computing, there are talks about quantum computing being used with IoT, cloud compute. Even some startups are using Amazon's cloud architecture to develop quantum computing solutions. So everything is so much connected. So when you think of blockchain, it's not a standalone technology, and neither of it is. You have to, connect everything. You have to be, interoperable. And who knows what next technology may be. So you have to be ready for getting merged with the new system, new technologies. So in combination of these technologies is how we find application of blockchain in the sectors we just mentioned. So yeah, that's it for this session. In the next session, so till now we only discussed about the patent analysis, the technical part of patent analysis. It was a little bit, it might have been a little bit boring for you guys because it's too much technical. And then we discuss about blockchain application, blockchain trajectory, that how blockchain has evolved since 1990, not just 2008, or Bitcoin or cryptocurrency part of it. So I hope I was able to get about this blockchain. Although I wanted to discuss about M-payments, Wi-Fi technology, but I think blockchain is, and because time is not enough, so, and blockchain is, current topic, so hot topic right now. So it's more interesting. It might have been more interesting for you. I will open the window for questions. You can write in chat, and we can have how much time do we have? We have 10 minutes, 10 minutes for the questions. So any questions?
So, audience, if you have any questions, any queries, please feel free to raise your hands or post your questions in the chat box.
Questions. I hope you have not slept. Is everybody awake?
I think everyone has cleared their doubt in the ongoing session only, right? Because in between we have so many. Yeah, I guess we have one questions.
How can we learn? How can we learn? Yeah, I have to. I'm sorry, I forgot to mention this. To understand about blockchain, even I'm not from a very. I have a background of programming and computer. I was a software engineer before, but I'm not that into programming and everything, into technical, I would say. So when I started learning blockchain, I was also as confused as anyone. So I started with reading industry reports from McKinsey, IBM, and Accenture. They have very good reports based on new technologies. So you can just search about them. They have a blockchain, Industry 4.0, quantum computing. So if you want to get a gist of what a technology is, what a what the trend is in technology or what it is projecting in the future. So they publish some good reports. And if you want to go into detail about patent landscaping or innovation landscaping of the matter, you can go to the patent database reports. You can go to USPTO website. I have shared in the PPT before in the session, and you can go to WIPO website, Patentoscope. They have this particular page for green energy patent classifications. So these are some initial initial go-tos to get you a basic understanding of a technology, especially in blockchain or industry 4.0, IoT, big data, anything. And then I mentioned earlier also, there is a course on YouTube free of cost. It's MIT's open courseware about blockchain and money, and the instructor is Gary Lesner. It's a very good detailed course, not technical, but with management application. So you can go through that course on YouTube, or you can also find that on the MIT website. They have all these PDF and assignments also on the website. So MIT course where you can, I'll write it down in the chat box. MIT courseware, blockchain and money, about by Gary Lesner. Then you also can find EDX courses on blockchain, which you can audit. And if you want to get a certification on, you can pay for the course, but you can go for free audit for them. It is limited time, a limited time frame. And they have this fintech and blockchain applications by Linux. Also, Linux has their course on EDX, and Coursera also has. But on EDX you can at least audit for free. You don't need to pay money or give your visa details like that. So you can just they have EDX has a course by Hong Kong University about fintech and blockchain, and then they have Linux has their course, MIT has their course on. Harvard has their course on blockchain or any technology you want to discuss or learn about. So you can go through these, but you need you need to be consistent and have time to go through these courses. But they are really good if you don't have the technical background in this technology, to get the basic understanding of what blockchain is and what its applications are. And what's the next question? If blockchain is incorporated in academic learning, will it be able to replace traditional teaching, physical and online both? So how do you think, Mr. Asad, how do you think the blockchain will replace the physical or online? It can only assist in the teaching. I mean, okay, Mr. Asad is raising the hand. I'm going to allow you to talk. Are you going to ask, or I can just answer the question in your chat?
Good afternoon. Can you hear me?
Yeah, good afternoon. Good afternoon.
Okay. Yeah. I'd just like to introduce myself. I'm Asad Khan. I'm a research scholar as well as I'm a teacher.
Great.
So I asked this question.
I was just going to reply to that.
Because we have seen in the past 1 decade, there have been so many changes in academics. Okay. Because of pandemic, we were there was no other option but to go online. And that's how online has been incorporated and accepted also in the academic industry now. So I was just thinking about it because since with the help of blockchain, all we do see a lot of online courses nowadays, and even the governments are taking initiatives. Recently, UGC has passed one regulation wherein it has allowed 900 top institutions to run online courses. So it will be authentic also now, since the government is allowing it. So that was my question, that definitely blockchain will help in developing the content and making it available. That content will be authentic also, since it will be backed by technology. So repetitive content cannot be posted. So there will be a catch in it. So that was my question. Will teachers, the academicians, these professionals will their role change with the passage of time as more and more technology is adopted and incorporated in the teaching pedagogy? So, or they will not be like now in traditional method, what used to happen, whatever content according to the syllabus we prepare, so we keep modifying it, but we deliver the same content in every lecture. So lectures will not be repeated. If there is a content which is available to students online, like in most of the online courses, so one teacher has to record one lecture and make it available to the students. Then students, they listen to the content, they learn from it. And for discussion, of course, there are discussion sessions in which the queries are discussed. So, what will be the role of academicians after this is incorporated and it becomes more widely used by various institutions? What will be the
Yeah.
role of teachers then?
Yeah, it's a very insightful information and question both that you have put very, very thoroughly. You have given this question and given this understanding. But I think academicians or teachers will have to obviously upgrade themselves as well in terms of blockchain ecosystem if it's incorporated. But then again, I think even if blockchain is incorporated in academic learning, or blockchain based academic learning, or blockchain courses or whatever, or even the online system of blockchain based on blockchain, then it will be the base in, basic backend in the online worlds that we are in now. Like we are using Zoom, we are using MS Teams, we are using some other infrastructure, some other application. But then we have to adapt to it. We have to upgrade ourselves. So it also depends on I think it depends on the willingness of academicians. But I think last 2 years have given us a very good example of how we can evolve, upgrade ourselves in terms of technology. Many teachers have been trying really hard to understand the technologies, the whole this ecosystem of technology. So if we are incorporating blockchain in the academic learning, if we are incorporating blockchain-based systems in academic learning, so I suggest, I think that it would be, first of all, it would be like, it will begin with a little bit of training for them. And then it would also be like how these systems work together, like physical and online. Shall it be hybrid, or how can you modify a physical system based on blockchain? How can maybe an attendance record system we can begin with, or maybe a system where student marks are stored in this. But then the academicians might just get the user interface and not the background technology. So for them, it will be just like just today, I give you an example of patent analysis. But I know that not every venture, or not the business, not the entrepreneurs will not be doing this patent analysis. They just use this technique. Maybe somebody else does this for them, and they just get a little bit of training for that. And I think Dr. Vinayak has something to say about this.
Yeah,
because he's an academician here. So
okay, so thank you. Okay,
Yes,
so Asad,
Yes,
I
sir.
really appreciate your question and this timely
Yes.
question. But then we have to
very
understand.
timely question.
Yeah, we have to understand that you are mixing two things in one, right? One way you are asking like what will be the role of the faculties or even the person who is actually adopting these new systems. And the second question is how this particular technology called blockchain will going to change the face of the knowledge sharing platform, right?
Right.
These are two different questions you need to understand. So in past 2 years, we have already adopted the technology which has already changed the platform and the faces of the knowledge sharing avenues, right?
Right. Sir.
This is already happening. But is the role of the knowledge means facilitator? So I always consider myself as a facilitator, and you are being a teacher also, right? Our role is still there, right? So whether now we are using digital content, right, irrespective of in the previous time we are using the physical content where we used to write on the board and then delineate the knowledge to the students. Currently we are using the physical digital content rather than physical content, but still ensuring that content to be administered in the class is a duty of a facilitator. No technology is actually ensuring this. So being a facilitator, your role is expanded rather than becoming shrink. Your role has been expanded. Expanded to what level? That yes, you have to cope up with the technology, whatever technology is happening, whatever technology is blooming. Yes. But the thing is, the role of a facilitator will never being actually flipped or eliminated by any of the technology. You need to understand.
Definitely agree to that.
Right. Another thing, as you mentioned, like, okay, blockchain technology or any other disruptive technology will actually change the way we are doing the thing. So we need to understand that whatever technology or whatever patent Ms. Bhatt has explained to you or discussed, right? These patents and these technologies requires a infrastructure, right? Why I'm saying this, and if you take the example of the top-notch colleges in our country, whether it's an IIT, whether it's IIMs, right? Even they don't have that kind of infrastructure to even cope up with basic technologies like RFID, right? So it's not the overnight change, whether it's a disruptive technology or a competitive technology. We need to understand that what is, first of all, what is the role of that particular technology? And here the role of the technology is the assistive, right? So assistive, so it will not going to change the role of the facilitator, to be sure. Yeah, facilitator has to enrich themselves in such a manner that they can actually understand this assistive technology. So understanding, for understanding the things and make our students to understand, you need to put extra effort.
I would like to add here that before the pandemic, I would say that you would see teachers or academicians very reluctant to adopt the new technologies sometimes. At least in my experience, I have seen in Indian context, many of them are adamant to accept the new technologies or even discuss about them. But with the role of with the pandemic, I mean, for 2 years, when online studies, online education became mandatory, like you have no other option, and there we see the willingness of people, willingness of some new teachers, new academicians, trying to really impart their knowledge through this online system or whatever system they were given. So it's just the willingness of how the academic ecosystem wants to incorporate even the blockchain or any new technology in their whole ecosystem. So I think it's the willingness and the assistiveness of the technology and willingness of the academic ecosystem more important.
Also, the purpose of blockchain is not to eliminate the existing process, but to make the existing process more transparent in nature, right?
Yeah.
As Asad
blockchain helps actually in transparency, because you cannot imitate, it's immutable, and it's just everything is secure. So you have the chain with you, and all the stakeholders in that are notified. If you go into the detail of blockchain technology, every stakeholder is notified about the change, so it's more transparent in that way.
So as Asad mentioned about a very right thing, that this particular technology can actually help the organization to remove the overlapping content in the code.
Yes,
that's actually right. But again, in that role also, technology is playing as a role of a complementary thing, right? It is not removing the facilitator. So that's why we need to make a very clear distinction between the purpose of the technology and the use of the technology. So the role of a facilitator will get extended because you have to put more efforts to understand and adopt that particular new platform things, or you can say new process phase. Right?
Right. Thank you, sir. Thank you, Vinayak, sir. Thank you, ma'am, for answering my question.
Thank you for such an insightful question, actually.
Yeah, you're welcome.
I'm just going to disable your any more questions? Anyone? You can ask on the chat or raise your hands. Or anyone has anything to add to this discussion today, based on patents, based on blockchain, or any technology you want to discuss? Nobody?
Okay, I think we have already accommodated.
I think they are totally exhausted by now.
Yeah. So, yeah, but I can understand. But thank you very much, first of all, the audience who has actually shown their patience to be here, and they have actually interacted very well. So this today's session is much more interactive than the yesterday's session. And yeah, so we have two more sessions post lunch, right? So first session will be is on basically we have one more expert talks, right? And then he will talk about the ecosystem, how the ecosystem is actually required for technology, any competitive or disruptive technology. And then another followed with the session where I'm going to talk about the applications of the mind technologies, right? Because
I would add here that Dr. Vinayak will just move ahead from where I have stopped here in this session, that I showed you the networks and clusters, but he will talk more about the managerial aspects of these results. So I just wanted to add this here.
Right. So those who are interested in understanding the application of whatever we have mind. Okay, so first process is to first of all understand the technology, understand the course, roles and positions of the technology. Now once you understand, what will be the avenues for the MSMEs and the new ventures to develop some new services or to change in the existing product line? So that part we're going to discuss in the post session series, right? And I again expect you all to be there, and then in the end we'll definitely have a discussion session, right? We also expect you to be there, because then those who are only finishing this particular sessions, they will be like given the certificates of completion, right? And that's something which again it's something which is important for all of us, right? So before ending this session, I don't think we have
questions. Sorry to interrupt, I have one more question.
Yeah, I guess
Mr. Shaswat is asking, how much is must for a person to know about blockchain and similar technologies? Like I mentioned before, to get initial understanding of any technology or blockchain, you just go through the industry reports or patent database reports. You will get whole more information in less pages, and you will just get the know-how of what all these things are about. And then if you want to go into, you want to move ahead, you want to go more further, you can go into the courses that are available on YouTube and these edX and Coursera, or you can just go through you can also find some books or I would say for more detailed, or you can, if you want the technical part of it, you can go to GitHub or Kaggle to understand the data sets based on blockchain or any technology and see what the competitions are going on there. So that's it. That's how you get to know about the technology. And I mean, that's the starting point. Okay, so.
Okay, once again, I think we have answered all the questions. Yeah, it's already we are past 5 from the session, right? Yeah.
Yes. So I want to thank all of the audience members for being alive for three hours. And so thank you all of you for an interactive session as well. And
thank you, Ms. Bhatt, for sharing the knowledge with the people, those who are really looking to adopt the blockchain in future. Thank you very much, and see you. Have a great day.
मैं तो खाना खाने जा रहा हूँ, तो जाओ। हाँ, P4 में टॉप फ्लोर पे खाना, तो कोई आया ही नहीं वहाँ, सारे
Vikas, are you there?
Yes.
So live streaming is stopped, right? Paused, right?
No, sir. It's live.
Okay. Okay. We can pause it because our next speaker will join us in a few moments. Okay. Hi, Mr. Bajpai.
Hi guys.
Hi. Is it possible for you to open up your camera? I'm not able to see you.
Yep, 1 second. Okay.
Yeah.
Okay.
Cool. Cool. So how are you?
Fine, thank you. How are you doing?
I'm doing perfectly fine. Yeah. Okay. So I guess so far we have 30 participants and we have given the time at 2. So we can wait for next 5-10 minutes
Mhm.
and then we can start the session.
Sure.
Vikasji, can you please make our speaker as a co-host so that he can actually...
It's already done.
Okay, okay. Thank you, thank you. Mr. Bajpai, can you please check the options you have got?
I have who can share, only host or panelist.
You can unmute the participants also.
Okay. Okay. Perfect. If I want to share my screen, I'm getting the option.
Yeah.
Okay, and I think the participants can also do some can ping some messages on the chat.
Yeah, they have that right to post their messages, queries on the chat. But if they want to speak or if they want to interact, they will raise their hands and then you will unmute them.
Okay.
And that's perfectly up to you if you want to take up the questions in between the session or by the end of the session. That's completely up to you.
Yeah. Okay, meanwhile we wait, I would like to ask a general question to all our participants. I would like to know which areas you are already working on, means which sector. Is it manufacturing, product designing, supply chain, or yeah, any services? It would be good if you could write on the chat that which is the industry you guys are working on, so that I get a general feeling that, okay, this is the crowd here, and we can also have some examples in that directions.
Okay, so participant, you can actually respond on the chat box, like because the speaker can actually tweak the things according to the crowd. So those mostly or majorly, Mr. Bajpai, the participants, they are coming from the manufacturing sector, and we have few eminent scholars with us also, those who are working in or those who are doing their research in manufacturing and the supply chains. Also, we have young brains, those who are in their bachelor's and master's, and they are looking forward for new ventures. So we have a pool of different stratas, right?
Okay.
So that's the whole combination we have for today's session.
Okay.
Yeah.
Good. So we have a mixed batch.
Yeah, we have a mixed batch. So in the morning session, they have already got the understanding of blockchain technology, and now they are little better when it comes to technology as whole, right? Because we have tried to bifurcate the technologies in the components. So now the audience is pretty mature to understand how the technology can impact the industrial ecosystem too. And this is a very relevant thing when it comes to the indigenous market, or you can say indigenous ecosystem. So I guess, yeah. So it's two, I guess, Mr. Bajpai, we can start the session and then gradually audience will join and they can pose their questions. Yeah.
Good. Then welcome all to the session of technological impact on the industrial ecosystem. I'm Siddharth, as you might have known from our discussions. I would request that, yeah, let's make this session as more interactive as possible so that we can gain more out of it. Yeah. So as we have a mix of people here from different backgrounds, different industries, and they are working in different directions. So I would try to give you certain examples, but it would also be good if you have some queries, you can directly ask me, raise your hand, and we see that and we interact on your query, what we have. Okay, so let's start with the first topic of introduction. So currently we are living in a post-corona world. And this is, in this world, the word technology has spread more rapidly as we have seen in the previous years. Like now, the the normal household guys are also talking about technology. So it is not just limited to the technological firms or industrial process. Such a drastic change in the understanding and in the consumer behavior, this is very useful. Sorry. So such a drastic change tend to have a impact on the consumer behavior. And when you have a change in the consumer behavior, there is a possibility that our industry will also be impacted with this. Of course, always the industries had the technological advancement. They were always working on improving their production line, their efficiency, creating better products, and having some essential manufacturing things so that they can have the lesser turnaround period. But now, as the consumer is more aware, we see that this rapid adaptation of the technology has increased, and we see that there is a trend that next decade would be a decade of technology, where we say that these technologies are impacting every direction, every sectors of the industry. Yeah, and like I said, so you have a lot of technology. We see that there is a current hype of the technology, and we see that, okay, there are a lot of advanced and digital technologies available. Now, for a successful product, it is essential that we integrate these technologies into a physical act of manufacturing and supply. So in this session, we will talk about that, okay, how these technologies can impact our process of building the product, and how this process of building the product can help us achieve our expansion goals, our profits, and how it is beneficial for our company. So we would start with, in this session, we'll start with the pillars of industrial ecosystem. I've chosen 4 pillars. We'll talk about the product engineering. As the name suggests, in this product engineering, we would see that how the product is designed with these technologies, what impacts we have, and how better we can leverage these upcoming technologies to develop a future product. Next, we talk about manufacturing, how these technologies have impacted our manufacturing techniques. We talk about the latest techniques. We cover that, okay, these techniques, how they are affecting the maintenance process, the production efficiency, and how we get the return on investment. After this, we would talk about supply chain, where we talk about, okay, how we provide better risk management in the supply chain, how we improve the logistic efficiency, and such things. Later on, we have the services, where we say that, okay, how we maintain the quality or the brand for each customer, how we make sure that the customer, when they use our product, get a better feeling or get a good experience out of our product, and how we can leverage these new technologies which are in the market to improve our customer services. Yeah. So these are the 4 directions we will talk about in our session today. Okay, coming to the next first topic, product engineering. As the name suggests, product engineering means that we would be working on designing the product itself, like how we design the product. And usually these technologies can be divided into 2 major categories. Hello. How it impact the product engineering. Yeah, so the first area of impact where the product engineering technologies impact is the designing of the product itself. Here, the new technologies are impacting the designing of the product, saying that what is the best process, how we can design it, what all are the basic platforms, what are the different designing method, what infrastructure do you need so that you can understand how to design it. So it's the concept where you have to build the idea to a POC or a proof of concept, and then you have to build a prototype. When you build this prototype, you give engineers a feel that, okay, how these product or prototypes would interact with the customer in the field. The engineers get to know with this prototype that how their product is getting used, and then they can also tweak their product, make up their product more efficient, so that the final, when you release the product in the market, they are better adopted by the customer. The second area itself is adding the new features to the technology, new features of technology to the product. That means you design a product with these new technologies, and customer who is expecting that, okay, I have got something new, I have got something better, and we can also design something for the future. Like when you are designing a product which is having a life cycle of, let's say, 5 years, 10 years, 15 years, we need to make sure that the product which we have designed is relevant for next 10 years, next 15 years. And when this is the thought when you are designing a product, it makes better, or it makes sense that we think about the technologies which are developing now, and these technologies, if they go into the future, and how they are going to impact the consumer behavior. The longer our product covers these future technologies, more better our products would work. Yeah. So the first thing which I will start is like software or as a service. So one of these new technologies, we used to say that, okay, the world is going to be eaten by the software. All the old technologies, industries technologies, they were all converting into the software. Nowadays, the trend is very clear that each software is getting eaten by the service. What does this software as a service means? This means a service which is an intangible thing, and using this service which is intangible, you create something which is tangible. Chota sa example dunga for this here. I guess, I hope our audience understand Hindi also here. Okay. छोटा सा एग्जांपल दूंगा. पहले आप you used to see that okay, you have a software, like you have to buy the software. आप सॉफ्टवेयर मार्केट से खरीदते हैं. फॉर एग्जांपल अडोब का लाइट रूम प्रोडक्ट आता है, एक फोटोशॉप प्रोडक्ट आता है. पहले आपको पूरा एक लाइसेंस खरीदना पड़ता था, एंड देन यू आर द ओनर ऑफ इट. एंड if there is an update, if there is some updates, new technologies coming into, you have to buy a new license. आपको अपना डेटा अपडेट करना पड़ता है, आपको उस नए सॉफ्टवेयर को चलाने के लिए एक इंफ्रास्ट्रक्चर खरीदना पड़ेगा. लाइक एक आपको पीसी होना चाहिए, पीसी के एक मिनिमम रिक्वायरमेंट्स होते हैं. Nowadays it's all based on subscription. मतलब आपको एक प्रोडक्ट खरीदना पड़ेगा और आपको सिर्फ उतने ही पैसे देने हैं what is used for मीन्स आपको यूज करने के पैसे देने हैं, पूरे प्रोडक्ट और सर्विस के पैसे नहीं देने हैं. तो हाउ डज इट इम्पैक्ट आवर स्टार्टअप? फर्स्ट थिंग कि अगर हमने एक स्टार्टअप खोला या वी हैव अ इंडस्ट्री, तो पहला चीज जो एक पहली पॉइंट होता है कि आपको इनिशियल इन्वेस्टमेंट आपका कम हो जाएगा. मीन्स यू डोंट हैव टू बाय every infrastructure, you have to buy a server. No, you don't have to buy a server because now you have it as a service. मतलब आपने एक सब्सक्रिप्शन लिया, now you get all cloud, you get all the platforms and everything, and you just need a web UI or let's say a interaction. एक लैपटॉप दो डेवलपर को और एक लैपटॉप अपने इंजीनियरिंग टीम को दो, and they can use these services and start developing the prototype directly. तो इससे आपका जो upfront investment होता है वो बच जाता है, आपका रैपिड टेक्नोलॉजी एडॉप्टेशन बच जाता है. मतलब आपको नया बिल्डअप करने के लिए इन्वेस्टमेंट नहीं देना है, आपको नया टेक्नोलॉजी यूज करने के लिए वो समझने की जरूरत नहीं है. यू जस्ट नीड टू नो हाउ टू यूज इट. So this is one of the service or the direction the world has moved on to, and you can see it everywhere. You can see that okay, there are apps which are subscription based. Now you do not directly buy the app, you have to buy it on a monthly basis. Second, like you are having the services for Photoshop, you don't have to buy it. इसका benefit जो user को होता है कि उनको बार बार लाइसेंस भी नहीं खरीदना पड़ता है, and they can get an update. मतलब आपको अगर अपना प्रोडक्ट को मार्केट स्टैंडर्ड पे रखना है तो you can always get an update which are being pushed every month by the services. Software as a service का एक और फायदा ये है that you can create a new business plans. Instead of one-time revenue, now you can have recurring revenues. It means कि आप एक सेट कस्टमर बेस बनाते हैं, एक लॉयल कस्टमर बनाते हैं कि जिसने आपकी सर्विस ली, उसने उस सर्विस को यूज किया, and while using he liked it and he can keep on continuing using the same service. तो ये आपका सॉफ्टवेयर एज अ सर्विस का एक ट्रेंड है जो आजकल बहुत चल रहा है, and the whole world is moving towards it. दूसरा ऑप्शन आता है वॉइस यूजर इंटरफेस. इसका क्या मतलब होता है? इसका मतलब बेसिकली है, सिंपल एक एग्जांपल है वॉइस यूजर इंटरफेस Alexa. Every phone has a voice user interface, either it's Siri, Alexa, Google or OK Google, anything. एक ये ट्रेंड है कि आपने जैसे अपने स्टार्टअप में कोई एक प्रोडक्ट बनाया, then you don't have to have the complete overall high processing कि भाई natural language processing feature उसमें होना चाहिए या फिर लेटेस्ट क्लाउड कनेक्टिविटी रहनी चाहिए. उसमें बस ये रहेगा कि आपको मिनिमम अपने फंक्शंस का एक रिसोर्सेज वाला देना है, एक माइक्रो कंट्रोलर दीजिए छोटा सा, आपका एक प्रोडक्ट बन गया. एंड what you have to do is provide an API or access to these user interfaces which is connected to the cloud or which is connected to the user already. तो आपका अगर नया प्रोडक्ट है, ये आपने मार्केट में उतारा, the best thing of this is that user already knows how to use it. उसको क्या करना है कि Alexa से जोड़ना है और Alexa को कमांड देना है कि Alexa ये प्रोडक्ट यूज करो, उस प्रोडक्ट से कहो कि ये मेरा काम कर दे. दिस बेनिफिट ये रहेगा कि जो कस्टमर है उसको कोई नया चीज लर्न नहीं करना है, और आपको प्रोडक्ट को इतना भी रिसोर्सेज और इतना कॉस्टली भी नहीं होना है कि उसको ये सब टेक्नोलॉजीज यूज करने के लिए, रन करने के लिए उसमें खुद का प्रोसेसिंग पावर होना चाहिए. सो इससे आपकी कॉस्ट बचती है फॉर मेकिंग अ प्रोडक्ट, और इससे कस्टमर का भी फायदा होता है कि ही डजंट नीड टू अंडरस्टैंड कि आपका प्रोडक्ट यूज कैसे करना है, ही डजंट हैव टू रीड द यूजर मैनुअल, उसकी आदत नहीं बनानी है. This is voice user interface. Next is cloud computing. I think everybody has heard about this. Here you do not need the resources to be, or the infrastructure to be built in your company. Cloud computing में क्या है कि there are companies and there are things, firms, they are exporting their cloud infrastructure to you. You have the data, you send this data to the cloud, and cloud will tell you how cloud will have all the infrastructure to convert, do a big data analysis and make a data set out of it and do some usable things. इसका फायदा आपके स्टार्टअप में इसका फायदा ये होगा कि आपके पास एक जैसे एक बड़ा डेटा आ जाता है, आपके पास एक बहुत बड़ा डेटा आया, you don't have capacity to use that data. You can push it to the cloud and cloud will do all the processing and give you the analysis out of it. Next one is about the edge computing. Edge computing में क्या होता है कि you do the analysis on the spot with your handheld devices in the real time. So ये cloud और edge में difference है. जैसे cloud को आपको data cloud आपको push करना पड़ेगा remote location पे and they do the computing and send back the information. Edge computing में क्या है कि आपके पास data वही on the spot process होता है and you get a real time data. Difference ये है, cloud में you need to be connected to the internet, and edge computing में you can also process this data at the remote locations. एक example इसका मैं ये दूंगा कि like in a mining sector, हमारे mining sector में आप बहुत remote location में जाते हैं, there different machines लगाते हैं, different belts, conveyor belts होते हैं. हम IoT के थ्रू this conveyor belts को monitor करते हैं कि ये conveyor belt अगर सही चल रहा है, what is the speed of this conveyor belt, क्या ये conveyor belt टूट गया है, क्या ये conveyor belt पे load proper है कि नहीं है, ये सब monitor करने के लिए एक IoT device भी लगाते हैं. Edge computing का ये फायदा होता है कि you do not need to wait कि भाई आप जंगल में हैं या कहाँ है तो आपका क्लाउड पे पहले पुश हो और फिर वहां से कन्वर्ट करके वापस आपके पास आए. एज कंप्यूटिंग में ये फायदा रहेगा कि आपको वहीं का वहीं प्रोसेस डेटा मिल जाएगा, एंड व्हेन यू गेट दिस प्रोसेस डेटा यू कैन इन्फॉर्म द ऑपरेटर कि भाई दिस इज द प्रॉब्लम, दिस इज गोइंग टू चेंज एंड यू नीड टू डू इट क्विकली. और रियल टाइम में ये फायदा होता है, यू कैन डू अ प्रिवेंटिव थिंग्स बिफोर दैट. सो ये चार वन ऑफ द फ्यू टेक्नोलॉजीज हैं जिसपे आजकल प्रोडक्ट इंजीनियरिंग में बहुत काम चल रहा है. Now the question comes कि ये हमारे startup, you see that there are thousands of technologies. How does this impact our startup culture, or what technologies to invest in? So here I show a graph, hype graph of the technology की different technologies, what you hear in market, what you see in market, how it is going to have an impact on this, which technologies you should adapt for your own product. If you see on the left side, we have the innovation trigger. ये एक starting phase होता है that you have received a big technological breakthrough. You have received that, okay, there is a new technology, there is a media hype about it कि भाई ये बहुत है, future में आने वाला है, and then इस phase में लोग इन टेक्नोलॉजीज को उठाते हैं, they start trying to create a POCs or try to do some initial proof of concepts. इस phase में usually these technologies do not have a solution in the market. आपके मार्केट में कोई solution नहीं है. Nobody has proven कि ये चलेगा या नहीं चलेगा. It's all experimental and media hype. But these are the technologies where most of the researchers and let's say the guys who are working on the forefront of the technologies, they work in these areas. तो जब technologies यहाँ पे होती हैं तो it's mostly कि हाँ, there's just experimental hobby or researching. As you can see right now, this is the data from 2021. We have something called quantum ML. So using the quantum computing, we do the machine learning. Here you see that this is just the beginning of the cycle. ये अभी इसमें थोड़ा breakthrough मिला है, quantum computers बनना start हुए हैं, and they are trying to use it for the machine learning. Expected है कि quantum ML का plateau or the final part when the quantum computing or machine learning can be used in the market as a commercial product, it will take more than 10 years or so. This is expected. So ऐसे ही computing different technologies हैं like generative AIs. Generative AIs, we have done some research, we have done some proof of concept, but no viable solutions is still available. And it is expected कि ये market में अगले 2 से 5 साल तक थोड़ा commercial product के area में आएगा. Then the next phase of these technology come as which is called as peak of inflated expectations. In this part, the initial media hype has died down. मतलब इतना publicity वगैरह अभी हो गया है, और you have an option like आपके पास success stories भी आएंगे अब कि देखिए certain proof of concepts, certain experiments have been successful. These are like experimental demos people have given, and there they are working. There they are working. But इनके साथ ऐसा भी होगा कि आपके पास फेलियर स्टोरीज भी बहुत होंगी कि इन लोगों ने यहाँ पे डिप्लॉय किया पर ये चला नहीं, इन लोगों ने यहाँ पे डेमो एक दिया बट इट फेल्ड इन द फील्ड. तो ये जो फेज होता है, इस फेज में कुछ कंपनियां होती हैं who try to adopt these technologies, emerging technologies, but most of the companies do not. So according to 2021 August survey, we see that these are the technologies which we can think about of using in our product. Now, why I'm only focusing on first two, like innovation trigger or peak of inflated expectation में ही focus कर रहे हैं. The reason is when you are defining a product or when you are designing a product, you have to design it for the future, like depending on what is your lifetime of the product you are deciding. Do you want to design a product for 2 to 5 years, or you want to design a product that is being used in 5 to 10 years? So depending on that, you decide that, okay, these are my future technologies, and I have to keep an eye on these technologies, that if they are getting updated or how they are being developed in the market. And if these technologies become wide adapted, then my product should be able to use these technologies. So emerging technologies, that's why we focus only on these two areas as of now. This was this was on all about the product engineering. I give you one example or a case. I give you one case of connected cars. आजकल connected cars market में बहुत ज़्यादा it's kind of a hype. You see that there are multiple OEMs who are working towards it. The best example is Tesla car. There are other companies like Volkswagen who are creating this connected car concept. They are Bosch, Daimler, every known OEM or company, automotive company is working towards the connected car. इस connected car का simple concept है कि we take an industrial product, which is a car, जो एक offline product था, it was just a produce of industry, and now we add a cloud connectivity to it. Once this is connected to the cloud, we get a host of new add-ons, new technologies that can be leveraged. So, अगर leveraging technology का एक example दूं, based on this connected car is that, okay, you have a cloud connectivity. Now you can share the data or you get the data from the cloud, and the consumer who is driving the vehicle can get the information like where is the nearest petrol pump. तो ये कंज्यूमर एक्सपीरियंस में आता है कि भाई उसको पेट्रोल खत्म होने वाला है, उसको पता चल गया कि हाँ यहाँ पे नियरेस्ट पेट्रोल पंप है. दे गो स्टॉप एंड दे स्टार्ट फिलिंग इट. सेकंड, आपका अगर कार कनेक्टेड है, देन यू गेट द केसेस लाइक डिजिटल की शेयरिंग, you get कि आप अपनी की जो है डिजिटल की को भी डिजिटल कन्वर्ट करके आप शेयर कर सकते हैं अपने फ्रेंड्स के साथ, तो यू डोंट हैव टू बी फिजिकली नियर द कार. जैसे आपके दोस्त को आपकी कार चाहिए, सो ही सिंपली कॉल्स यू अप एंड से आई नीड योर कार. देन व्हाट ही डज इज सिंपली what you do is simply give him the permission on your phone, और वो डिजिटल की उसके फोन पे जाएगी and then he can access the car and drive away. This is one of the add-on or a new technology for the car. So using this hype technology of cloud connectivity, what these manufacturers have done is एक industrial product को लिया, एक physical product को लिया, and then they have added that they have expanded this technology. You have more better use cases, you have more add-ons, or add-on services can be sold to each and individual customers based on their requirements, or if they feel, yeah, this is a cool feature to have. Next is about rapid adaptation. So again, I will connected car case में अगर आप देखें तो mostly the OEMs जो हैं वो industrial based होते हैं. They know how to manufacture, they know how to produce a car in an industrial environment. But अगर आप connected cloud पे लेते हैं तो companies like Microsoft, Amazon, ये companies होती हैं जो they are working towards cloud IT infrastructure. So when you want to have a rapid adaptation of connected cars, what you have to do, आपको एक इन companies के एक service आती है, software as a service. You have to buy their Amazon cloud service. Then you have a cloud. You build up your application to it, and then finally you are ready to push your data and get all your application done through cloud. तो ये rapid adaptation हो गया. You don't have to build out the whole infrastructure कि कैसे कार कनेक्ट होगी, कैसे क्लाउड बनेगा. So this is an example of rapid adaptation. One second. Next option comes is messages आए हैं. Okay. Next use case is data-driven customer insights. What does this means? अगर आपने एक प्रोडक्ट बनाया, वो प्रोडक्ट फील्ड में गया है, you need to understand कि अब इस प्रोडक्ट के क्या क्या possibilities थे, how it was used in the car and in the field, and हमको क्या benefit मिलेगा, how to upgrade your product. So अगर आपको पता है कि कस्टमर फील्ड में डेटा के आपका प्रोडक्ट कैसे यूज कर रहा है, it becomes very good input for engineers to improve their product. और फिर उसका जो next version है और या फिर कोई next update है, you can push to the customer and you can increase the likeness of your product. So data driven customer insight is biggest example है Tesla. Tesla ने एक autopilot feature बनाया अपनी कार के लिए, and they pushed it down to the every customer, every of their car. Now these data, when the car has been used by the drivers, different scenarios are there कि हाँ भाई कुछ लोग सीधे चला रहे हैं, कुछ लोग पहाड़ में चला रहे हैं, कुछ लोग समुद्र के किनारे चला रहे हैं, कुछ लोग भीड़ में चला रहे हैं, कुछ लोग हाईवे पे ही चलाते हैं. डिफरेंट एक्सपीरियंसेस हैं, डिफरेंट डायरेक्शंस हैं कि डिफरेंट लोगों के डिफरेंट ड्राइविंग पैटर्न्स भी होते हैं. सो ऑल दिस डेटा इज कलेक्टेड एंड सेंड टू द कंपनी, और कंपनी में then you can analyze this data and see that okay, this is how my car of autopilot is being used, और उसको आप कस्टमाइज कर सकते हैं कि आप उसमें देख सकते हैं कि okay, these are the different cases, and हर एक केस के लिए आप बेटर सॉल्यूशन बना सकते हैं. तो this gives you a better customer experience कि हाँ आपने उनका स्टडी किया पैटर्न और फिर वही अपडेट आपने कार में पुश कर दिया. कार नोज कि हाँ कि इस पैटर्न पे ऐसे चलनी है, इस डायरेक्शन, इस रीजन में, इस एरिया में ऐसे चलनी है कार. सो इट ऑल्सो गिव्स यू बेटर कस्टमर एक्सपीरियंस. तो दिस इज द केस ऑफ कनेक्टेड कार्स कि हाँ भाई आपको बेटर कस्टमर एक्सपीरियंस मिल गया, डेटा का ड्रिवन, आपके पास डेटा भी आ गया, तो आप अपना फ्यूचर प्रोडक्ट भी बना सकते हैं जस्ट बाय सिंपली एडिंग वन कनेक्टिविटी टू द क्लाउड. इसका एक और फायदा होता है कि अगर आप क्लाउड से कनेक्टेड है, यू कैन ऑलवेज पुट अपडेट्स टू द कार. तो इससे क्या होता है कि आप फ्यूचर प्रूफ हो जाते हैं। मान लीजिए कोई नई टेक्नोलॉजी आई या फिर आपने देखा कि हाँ हमारी नेविगेशन टेक्नोलॉजी थोड़ी इंप्रूव हुई है, you can push more maps, more different types of navigation technology to the car without recalling the car or without saying that okay this car needs to be replaced and you need to buy a new car. तो इससे क्या होगा, आपकी कार जो है वो थोड़ा more resilient हो गई to the future. You are more up to the mark with the driver. You are up to the mark with rival companies. So उससे आपको एक बेनिफिट मिलता है कि यू नो कि अगर आपको कोई सिक्योरिटी दिक्कत है, कोई सिक्योरिटी पैच करना है या फिर आपको कोई अपडेट करना है, यू कैन ऑलवेज पुश इट थ्रू द क्लाउड एंड यू आर मोर resilient in this direction. So this was the case of connected cars and how this connected car example is affecting our product engineering and what benefits do we get from these new technologies and the product engineering. I would open now to everyone. If you have any questions, you can post it or can ask. Okay.
So if our audience has any question, please feel free to post or raise their hands. Yeah.
Take 1 minute.
Yeah.
Okay. Now we come to the next pillar of industrial ecosystem manufacturing. The oldest pillar of industrial ecosystem. Manufacturing is the base of producing all the ideas, the different consumers and technologies to a physical, tangible product. Here I have chosen 4 different technologies like digital twin, predictive maintenance, robotic process automation, and additive manufacturing and 3D printing. So digital twin kya hota hai? I guess most of you would already know. Digital twin is basically making a digital or making your physical asset as a virtual copy of that. Means आपने एक physical machine लिया, आपके पास एक बड़ी machine है, एक physical machine है, उसको आपने उठाया, एक अपने virtual copy बनाया, आपके पास tab है, then you can see that machine. Machine is connected with sensors, different data is being pushed from that machine and you can actually read this data. तो आपको it's kind of a virtual copy जिसमें आपको पूरा view दिखता है कि हाँ आपका एक बहुत बड़ा asset है, बहुत बड़ी machine है and this is having heating parameters, कितना temperature है, कौन से parts ज़्यादा heat कर रहे हैं, कौन से parts में oil कम हो रहा है, कितने जो भी आपको मेजर करना है, जितना भी आपका रेलेवेंट डेटा उस मशीन से निकलता है, व्हेन अ पर्सन इज स्टैंडिंग नेक्स्ट टू दैट मशीन, वो जो ऑब्जर्व कर सकता है, व्हाट कैन रीड एंड मोर कैन बी पुश्ड थ्रू दीज सेंसर्स टू द वर्चुअल कॉपी. और आपको एक वर्चुअल कॉपी में अच्छे से आप 3D इमेज में देख सकते हो कि हाँ दिस इज लाइक हमारी मशीन है, ये पैरामीटर्स हैं, करंट स्टेटस ये है इन रियल टाइम. ये एक एग्जांपल है डिजिटल ट्विन का. अगर मैं आपको बहुत सिंपल एग्जांपल दूं डिजिटल ट्विन का, तो हमारे ओला उबर है. सो यू जस्ट ओपन द ऐप एंड यू सी दैट ओके आपकी कार कहाँ है, कहाँ मूव कर रही है, कितने एरिया में. इट्स अ डिजिटल ट्विन कि आपके पास एक फिजिकल एसेट है, कार जो आपने ऑर्डर करी है वो आपके पास आ रही है, एंड हाउ इट इज कमिंग, व्हाट इज द पाथ, हाउ मच फार अवे इट इज, ये आपको एक डिजिटल कॉपी में मिल जाता है. दिस इज अ सिंपल एग्जांपल ऑफ डिजिटल ट्विन. इसका क्या फायदा है मैन्युफैक्चरिंग में? इसका मैन्युफैक्चरिंग में अगर आप प्लांट फ्लोर शॉप पे काम कर रहे हैं, यू नो और यू सी दैट ओके दिस इज अ बिग मशीन. ये एक मशीन आती है, करोड़ों में आती है. आपको पता है कि ये मशीन बहुत इंपॉर्टेंट है, अगर ये ब्रेक डाउन हो गई या इसमें कुछ कंज्यूमेबल पार्ट खत्म हो गया तो योर होल प्रोडक्शन लाइन इज स्टॉप्ड. इट इज देन क्रिटिकल कि हाँ ये मशीन को प्रॉपर्ली मॉनिटर किया जाए. So usually you have maintenance team, the guy is standing next to that machine and just seeing and reading it. But पॉसिबल नहीं है कि यहाँ 24 घंटे कोई खड़ा रहे उसके पास, तो आपके पास हमेशा एक सिंपल है, आपने 5-6 IoT सेंसर्स लगाए, एक AI मेंटेनेंस, एक AI एल्गोरिथम से कनेक्ट किया, एंड देन यू सी दैट ओके ये डेटा और ये AI एनालिटिक्स दोनों मिला के आपके पास एक डिजिटल ट्विन में आपका डेटा पुश हो रहा है. एज सून एज समथिंग गोज बैड, कि आपका कोई भी पैरामीटर आपके रेंज से बाहर जा रहा है, यू गेट एन अलर्ट. So you don't have to be always standing there and being worried that okay this machine can break down. You always get an alert before, and you see that okay your production line is safe. This is the power of digital twin. Digital twin healthcare sector में भी use होती है, definitely not in India, but आजकल it's a new trend जो चल रहा है कि you also have a human digital twin. बेसिकली आपके पास बैंडेड शेप के या बैंडेड साइज के छोटे छोटे सेंसर्स होते हैं. यू पुट इट इन द पेशेंट्स बॉडी ऑल अराउंड इट, एंड देयर यू फाइंड कि हाँ आपने एक वर्चुअल कॉपी बना ली, आपको फिर मॉनिटर कर सकते हैं कि हाँ ये बंदा, ये पेशेंट के कहाँ कहाँ पे प्रॉब्लम्स हैं और हाउ ही इज वर्किंग. सो आपको रियल टाइम में पता चलेगा कि इफ ही इज अंडर ऑब्जर्वेशन, कि उसका हार्ट रेट कितना है, ब्लड प्रेशर कितना है. You will get it on your mobile phone or your tab, and you can record everything and see the trend that how he is changing. This would help the doctors and nurses to provide better health care. एक और ट्रेंड है डिजिटल ट्विन का कि you can also practice the surgery before you perform the surgery to the main patient. So you simply have the digital twin, or you just have a virtual copy of human, and you perform certain surgeries and see that okay if you do this, how the human body would behave. And then finally, once the simulation is successful, you can always have it on the patient. Digital twin technology अगर आप जाएं तो it can be like a very costly technology if you are monitoring a big huge asset, but it can also be as simple as a Ola app or a Uber app, where you simply see a car moving around in the given path and how far it is from you. Digital twin can be deployed in a less complex business scenarios also. Simple एक IoT sensor, multiple IoT sensors का data एक आप पेज में लीजिए, एक UI में दिखाइए, एंड यू गेट अ डिजिटल ट्विन. और इसका एक फायदा होता है, यू कैन ऑल्सो यूज इट इन डिजाइन कस्टमाइजेशन एंड इम्प्रूव द शॉप परफॉर्मेंस. डिजाइन कस्टमाइजेशन में ऐसे कि यू कैन यूज द डिजिटल ट्विन एंड देन यू कैन गिव इट टू द इंजीनियर, एंड इंजीनियर यूजेस द डिफरेंट कंपोनेंट्स और डिफरेंट परम्यूटेशंस ऑफ द कंपोनेंट टू सी कि हाँ कि you can create a personalized product for a consumer. Like for a digital twin, you can combine A plus B if equals to C, and this C is required for the customer or not. Or if you can also have A plus X, and you see that okay, if this C which is coming is equal or what is what the customer wants. So in the digital twin, you do not have to physically monitor or change the product. You simply take a virtual copy and you do certain changes and find a right permutation that will satisfy your customer needs. तो ये थोड़ा मॉड्यूलर डिजाइन में भी काम आता है. इसका शॉप फ्लोर पे अगर आप मैन्युफैक्चरिंग से हैं तो शॉप फ्लोर पे कितना फायदा होगा. आपने एक डिजिटल ट्विन अपने मशीन्स का बनाया, आपने प्रोसेस का, अपने नॉर्मल मैन्युफैक्चरिंग प्रोसेस का एक डिजिटल ट्विन बना लिया. नाउ यू सी एंड इंजीनियर्स उसको देख के एनालाइज कर सकते हैं कि उनका जो एंड प्रोडक्ट निकलेगा, इज इट ऑन द क्वालिटी स्टैंडर्ड, द राइट व्हाट द कस्टमर वांट्स, कि आपके एंड प्रोडक्ट्स जो हैं वो प्रॉपर परफॉर्मेंस पे काम कर रहे हैं. आर दे हैविंग इनफ क्वालिटी, उसकी सोल्डरिंग अच्छे से हुई है. if it's a PCB, does it have the right materials, the material quality is right, what is the error percentage. So all this can be calculated and seen through a virtual process digital twin also. Next we come to the predictive maintenance. Maintenance अगर आप manufacturing sector में है, you know it's one of the biggest critical job what you have in the production or the shop floor. अगर आपकी एक मशीन डाउन हो गई तो आपकी पूरी प्रोडक्शन लाइन कैन बी स्टॉप्ड. एक एग्जांपल है, आई वाज वर्किंग इन स्टील इंडस्ट्री. उसमें एक स्टील प्रेसिंग इंडस्ट्री होती है. एक मशीन होती है स्टील प्रेसिंग जो भारी मशीन होती है. इट हैज अ शाफ्ट ऑफ लेट्स से 16 मीटर बड़ी शाफ्ट होती है और अराउंड 2 मीटर्स डायमीटर की, वेइंग अराउंड 1 टन. सो अगर जनरली ऐसा होता था व्हाइल प्रेसिंग द शीट, स्टील शीट, वो शाफ्ट टूट जाता था. ये यूजुअली उनके साथ होता था एवरी ट्वाइस अ मंथ और एवरी फोर्टनाइट. उनके साथ एक बार ये शाफ्ट टूट जाता था. और ये शाफ्ट टूट जाता था, it would take around 16 hours to replace the shaft from the warehouse and get it installed on the machine. तो इस सिनेरियो में आपका प्रोडक्शन जो है वो 16 घंटे के लिए बंद पड़ा है. योर प्लांट इज मेकिंग लॉस फॉर 16 hours. In this scenario, predictive maintenance comes in picture. आपको पता है, आप एक सेंसर, 2-4 सेंसर लगाइए पूरे शाफ्ट पे या आप अपनी पूरी मशीन में, and they will continuously monitor your system or your machine. ये जब मॉनिटर कर रहे होते हैं, you have an algorithm running that can predict कि अच्छा your machine is working like this, it has these parameters, but within these time it will go out of range. मतलब आपका 10 दिन या 12 दिन में या फिर आपके अगले 5 दिन में, बेस्ड ऑन हाउ द मशीन इज राइट नाउ वर्किंग, दिस मशीन इज गोना ब्रेक डाउन. सो ये एल्गोरिथम्स पे ये पता करते हैं कि हाँ ये कब टूटने वाला है. एंड व्हेन यू नो दिस इंफॉर्मेशन यू कैन ऑलवेज हैव अ शेड्यूल्ड मेंटेनेंस. तो प्रेडिक्टिव मेंटेनेंस यूज करके यू कैन ऑलवेज प्रिवेंट द नेसेसरी डाउन टाइम. You can move the maintenance, you can always have the scheduled maintenance or a planned maintenance, which या अगर आपने प्लान किया है तो आप पूरी मेंटेनेंस, पूरी लाइन की मशीन्स का मेंटेनेंस एक साथ कर सकते हैं. यू आर नॉट स्टॉपिंग द प्रोडक्शन व्हेन इट इज मोस्ट क्रिटिकली नीडेड. व्हेन यू हैव प्रेडिक्टिव मेंटेनेंस तो आपको ये भी मशीन्स बता सकते हैं और द सेंसर्स बता सकते हैं कि आपका कौन सा कंज्यूमेबल पार्ट किस डेट तक खत्म हो जाएगा. Then you have auto-generated list into your system और आपकी purchasing team वो parts pre-order कर सकती है. You do not have to maintain these consumable part for like say 1 year for all machines. Yeah. So whenever you need those parts, you know that okay, you need those parts from the machine and you can then order it. So this is the predictive maintenance. Next comes robotic process automation. रोबोटिक प्रोसेस ऑटोमेशन इज, अगर आप नाम से सुने तो ऐसा लगता है जैसे जो बगल में इमेज बनी हुई है कि यू हैव अ रोबोटिक आर्म जो एक लाइन से उठा के सामान चल रहा है, बट इट्स नॉट नेसेसरली ऑलवेज दैट. रोबोटिक प्रोसेस ऑटोमेशन इज बेसिकली टारगेटिंग द मीनियल जॉब्स और द बोरिंग रिपीटेटिव जॉब्स. मतलब आपके पास एक ऐसी जॉब्स हैं जो एक ह्यूमन कर रहा है बट इट्स वेरी टीडियस. मतलब आपका प्रोडक्ट लाइन में चल रहा है, आप उठा के ऐसे साइड में रख रहे हैं और इट्स वेरी रिपीटेटिव. और ऐसा भी हो सकता है यू आर रेजिंग मल्टीपल पीआरस, परचेज रिक्वेस्ट एंड फाइनेंशियल थिंग्स. सो आइडिया इज कि अगर ऐसा कोई रिपीटेटिव प्रोसेस है जो कि एक ह्यूमन परफॉर्म कर रहा है, इट कैन बी रिप्लेस्ड बाय अ सॉफ्टवेयर. like simple software automation कर सकते हैं, or it could be a mechanical robotic arm or something, but it can be used to do these menial tasks so that the human who is performing it is free to concentrate on more complex and value adding work. Like अभी की जो मशीनरी है, जो टेक्नोलॉजी है, they cannot do 100% complex task. They can do simple task. Human अभी भी लगते हैं जैसे आपको multiple task, complex task करने हैं. तो you can remove those people and put it into more value adding task. For example, ऐसा होता है कि आपके पास एक ऐसा टास्क है जिसमें एरर्स होने की चांसेस ज्यादा है. अगर वो रिपीटेटिव टास्क है, बहुत सिंपल टास्क है, रिपीटेटिव बार बार रिपीट कर रहा है एक ह्यूमन, तो उसमें एक ऐसे एरर, एक दो एरर्स ऐसे होंगे कि जो बाई चांस हो जाएंगे बिकॉज यू लूज कंसंट्रेशन व्हाइल यू आर डूइंग दिस जॉब विदाउट फोकसिंग। तो ऐसे जॉब्स को सॉफ्टवेयर के ऑटोमेशन में बहुत आराम से यूज कर सकते हैं। फॉर एग्जाम्पल कंपनीज लाइक कोका कोला, Walgreen, these have streamlined their PR process and financial operations process to used by the robotic automation process. तो आपने एक set form बनाया, set process बनाया, if you click here, a PR would be generated and it would be streamlined between all the suppliers. तो इससे, this is one example of robotic process automation. Next comes additive manufacturing or 3D printing. Additive manufacturing, usually when you are doing manufacturing और आपको एक product या part बनाना है, then you do a subtractive manufacturing. That means you take a block of material and then you start shearing it into the shape what you want or the shape that part belongs to. अगर आपके पास इसको सब्ट्रैक्टिव मैन्युफैक्चरिंग कहते हैं, इसमें आपका मटेरियल वेस्ट होता है, आपको रॉ मटेरियल का ब्लॉक लाना पड़ता है एंड वो मटेरियल वेस्ट होगा। अगर आपके पास कॉम्प्लेक्स शेप बनाना है आपको, लाइक वन या कॉम्प्लेक्स शेप जिसमें 2-3 पार्ट्स आपस में मिलेंगे, लाइक लॉन्ग पार्ट देन वन सर्कुलर पार्ट टुगेदर, आपको थोड़ा उसमें ज्यादा इश्यूज बनते हैं कि आपको 2-3 चीजें मिक्स करनी पड़ेंगी। हो सकता है कि यू हैव टू आल्सो वेल्ड 2 पार्ट्स टुगेदर, सेपरेट आपने मैन्युफैक्चर किया और फिर उनको वेल्ड किया। So such spare parts, such small parts or complex parts, आजकल they are used via the 3D printing. 2013 में 3D printing was estimated to be worth around $3 billion, जो कि by 2017 it was up to $7 billion. Global market में expand हो गई, and by 2025 the market forecast that it will be around $20 billion on the 3D printing. So 3D printing is actually a manufacturing technique for the future. और इसका अभी भी mostly use start हो गया है, enterprise 3D printing start हो गया है if you are working for the customized spare parts. किसी कस्टमर के लिए आपको कस्टमाइज करना है स्पेयर पार्ट को, या फिर आपको वन एग्जाम्पल इसकी आपने कंस्ट्रक्शन इंडस्ट्री में आपने देखा होगा एग्जाम्पल और वीडियो कि यू आर यूजिंग 3D प्रिंटिंग टू प्रिंट द हाउसेस। ये इंडस्ट्री एक्चुअली बहुत ज्यादा पुश हो रही है इस वक्त, मोस्टली बिकॉज ऑफ द स्पेस रेस आल्सो व्हिच इज गेटिंग मोर हीटेड नाउ, द इंडिया इज आल्सो पार्ट ऑफ इट। स्पेस में आपको कंस्ट्रक्शन और 3D प्रिंटर्स, they are trying to send the 3D printers to space to print different parts or spare parts what might be needed by the astronauts. तो इससे जो टेक्नोलॉजी है आपकी बहुत ज्यादा पुश हो रही है which now can be actually commercialized for normal manufacturing and processing. आजकल एक ट्रेंड है external manufacturing, means you design a product and you simply send it to an external company to manufacture it. इस ट्रेंड में the company who is manufacturing it, they usually get a large order like 1,000 pieces or 10,000 pieces, 1 lakh pieces, or they can also get a small order like 4 pieces, 20 pieces or 30 pieces. So these companies have started using these 3D printing, 3D printers, enterprise 3D printers, so that they can also fulfill the orders of small quantities. एंड हर बार उनको डाई नहीं प्रिंट करनी पड़ेगी, उसके लिए एक डाई नहीं बनानी पड़ेगी कि हाँ ये डाई चाहिए, ये डाई बनेगी और फिर दे कैन प्रिंट दीज सेक्टर्स. नो, यू कैन सिंपली यूज इट एज अ 3D printing 3D printer, or you can make that complex spare part. And the best part is that this is additive, means you do not have to take a block of raw material and reduce it. It's simply that you take a raw material and you print it into the shape what you want. So इससे आपका रॉ मटेरियल की बचत भी होती है. Okay. Okay, good. Then if no questions, next here I show you the trend of the manufacturing technologies. Unfortunately, this is little old data, and I hope it's not too small. Okay. So previously for the product engineering, we talked about the first two graphs of, or first two blocks of the hype graph. Here we saw that these are the two best areas where we can start working on when you are designing a new product. But when you talk about manufacturing, it's mostly that we take these technologies from the slope of enlightenment and plateau of productivity. मतलब क्या है? When you have reached the peak of inflated expectations, आपके पास ऐसा कुछ सक्सेस स्टोरीज आ गए, कुछ अनसक्सेसफुल स्टोरीज आ गए, फेलियर स्टोरीज आ गए, फिर एक डाउनफॉल होता है कि यार ये प्रोडक्ट चलेगा नहीं. It might be that the technology dies during this trough of disillusionment. There is a chance that these technologies die, or there is also a chance कि जिन companies ने who are pushing these technologies, they only work for the early adopters. इस केस में जो आपके normal early adopters होते हैं कि नई टेक्नोलॉजी आई, there was a new product, first generation product, and there were few early adopters. अगर इन technologies ने इन early adopters को satisfy कर लिया, then these companies, if they keep on pushing to build a second generation, third generation of solutions for these technologies, they reaches the slope of enlightenment. That means once it has been second generation, third generation, then the industry starts to see that, okay, there is also a scope, or you can expand into different sectors, and there is more positivity about these technologies. And when we reaches this area, the manufacturing can pick it up. The manufacturers can say that, okay, this is now becoming a stable technology. It is having a commercial output, and these second generation, third generation products can actually help my manufacturing technology, or to build up my my prototype, or my end of line product. And here is where the most companies start adopting it. And and once the product reached the plateau of productivity, let's say now my maturity has stabilized, it is proven that this is commercially viable solution, different companies have started to use it. This is where the manufacturing technologies start adopting these new emerging technologies. For example, like I said, one example is external manufacturing. It has reached the plateau in 2019. That means since around 2019 or so, the trend of outsourcing the manufacturing has begun. So there are the companies or plants which simply says that, okay, you give us any of your product, like PCB manufacturing. There are companies which have like an online website. People can order small quantities of PCB from 4 to 10,000 to 20,000 or 2 lakhs, whatever be the size. And they simply outsource it to companies, mostly in the China. I think I know some industries in Gujarat also which do that. So if they take your CAD design, they take your layouts, and they print those PCBs for you, and they send it, no matter how much is the size or cost. So this is the external manufacturing which has plateaued here. As you can see, what we've discussed about 3D printing in the manufacturing operations. This is something in 2019 was like the first generation of product has been in the market. There were certain success stories, certain failure stories. But now in 2020, 2022, we see that 3D printing has somewhat reached the slope of enlightenment due to the push via space industries globally. And we see that, okay, this is slowly becoming a commercially viable solution for manufacturing. So this was about manufacturing technology. I have one use case here which I wanted to share, and how we can talk about different benefits of using these technologies. So the use case here is about the milk run optimization. So Basically, milk run is like in manufacturing on a shop floor, there is a backfeeder guy who takes the raw material from these different warehouses into a cart. एक कार्ट रहेगी उसके पास, उसमें जाएगा वेयर हाउस में, अपना सारा सामान भरेगा जो जो मशीन को चाहिए, एंड देन इट गोज टू द शॉप फ्लोर एंड दे पुट दीज रॉ मटेरियल्स नियर बाय दोज मशीन्स, सो दैट कि जब भी उन मशीन का रॉ मटेरियल खत्म होने लगे, दे कैन रीलोड इट एंड द मशीन डू नॉट नीड टू स्टॉप. फॉर एग्जाम्पल, एक वायर इंडस्ट्री का मैं एग्जाम्पल दूंगा इधर. जैसे इफ यू वांट टू प्रोड्यूस अ वायर विद नॉर्मल इलेक्ट्रिकल वायर, जिसपे एक रेड ब्लू रेड एंड ब्लैक वायर होते हैं, ग्रीन ग्राउंड का वायर होता है, तो 3 वायर होते हैं एंड इट इज रैप्ड विद द ब्लैक वायर. नॉर्मल आपका इलेक्ट्रिसिटी का वायर है, यू नीड टू प्रोड्यूस दैट. शॉप फ्लोर में आप जाते हैं तो लाइन से मशीनें लगी होती है. एक मशीन होती है जो आपका कॉपर को स्ट्रैंड करेगी. Then there is the next stage where the two different copper stand, these copper stands are encapsulated by the PVC, like red color का PVC उस पे चढ़ाएंगे, coating चढ़ाएंगे, black color का चढ़ाएंगे, green color का चढ़ाएंगे. Then you go to the next step where they will wrap it around, twist them together, and then in the next step there would be a machine that would lay the black cover or black piece PVC on that. And then you have the complete big wire with 3 core and different colors. Now in मशीनों के लिए क्या चाहिए होता है आपको कि आपको different color के PVCs चाहिए होंगे, red, green, black. आपको copper wires चाहिए होंगे पहले स्टेज के लिए कि different copper wire के spools लगे हुए हैं और मशीन उनको एक 3 wires में divide कर रही है with number of strands. फिर नेक्स्ट स्टेप में आपको चाहिए होगा कि हाँ एक ब्लैक पीवीसी, बड़ा पीवीसी मटेरियल जो आउटर लेयर होती है वो कवर करने के लिए भी आपको चाहिए. सो ऑल दीज मटेरियल्स नीड्स टू बी प्रोवाइडेड टू द मशीन की वो जो कंटिन्यूअस वायर निकल रहा है. लाइक कस्टमर के ऑर्डर आते हैं कि आपको 2000 किलोमीटर ऑफ वायर चाहिए, 1000 किलोमीटर ऑफ वायर चाहिए. सो ये जो मशीन है इट कंटिन्यूअसली प्रोड्यूसेस दोज वायर्स एंड विद डिफरेंट लेंथ. इफ दिस वन ऑफ द मशीन स्टॉप्स कि भाई आपका ग्रीन पीवीसी खत्म हो गया है तो योर होल प्रोसेस इज स्टॉप्ड हियर. मिल्क रन का काम क्या होता है कि ऑल दीज रॉ मटेरियल्स, कॉपर, पीवीसीज, डिफरेंट कलर्स के पीवीसीज, डिफरेंट मटेरियल्स ऑफ ग्रेड ऑफ पीवीसीज, आपको राइट अमाउंट में राइट चीज आपको उठानी है, अपने कार्ट में डालनी है एंड यू हैव टू गिव इट टू द मशीन ऑपरेटर्स कि जब आपका स्पूल खत्म हो जाए या जब आपका वायर खत्म हो जाए, पीवीसी खत्म हो जाए, दे कैन इमीडिएटली रिप्लेस इट so that there is a less downtime of the production market and your line speed maintains or line speed increases. तो okay. यहाँ पे हम लोग एक टेक्नोलॉजी यूज करते हैं कि सिंपल प्रिडिक्टिव टेक्नोलॉजी यूज करते हैं कि हर एक मशीन में सेंसर्स लगे होते हैं. जब मशीन के पास दीज पूल्स आर गेटिंग ओवर कि उनको लग रहा है कॉपर खत्म होने वाला है या फिर ग्रीन पीवीसी मटेरियल ज्यादा यूज हो गया है, वो खत्म होने वाला है, इट गिव्स ऑर्डर फॉर्म और जनरेट एन ऑर्डर डायरेक्टली टू द वेयर हाउस. और वेयर हाउस को पता होगा कि इस कलर का मटेरियल, इस ग्रेड का मटेरियल इस मशीन में जाना है इतने टाइम के अंदर, एंड दे प्रिपेयर दिस मटेरियल्स एंड पुट इट एंड मेक इट अवेलेबल. तो जब कार्ट वाला बंदा आता है, जिसके पास कार्ट है, वो उसके पास जाएगा, उसके पास पूरी लिस्ट रहेगी कि उसको ये मटेरियल चाहिए और ये मशीन में जाएगा इतने इतने टाइम में. तो ही सिंपली पिक्स दोस मटेरियल्स, पुट इट इन द कार्ट और उसको एक प्रायोरिटी से डिफाइन कर देगा कि भाई ये वाला अभी तुरंत चाहिए, खत्म होने वाला है जल्दी, ये वाला बाद में चाहिए. एंड दिस टेक्नोलॉजी विल ऑल्सो टेल यू कि मिल्क कार्ट वाले को बताएगी using indoor positioning, it will tell you कि ये रास्ता अपनाना है, पहले इस मशीन के पास, फिर यहाँ से दूसरी मशीन के पास, फिर यहाँ से इस मशीन के पास ये वाला मटेरियल देना है. So the chance of giving wrong grade of material, wrong color of material and not providing the material on the time is highly reduced. The machine gives you that order, machine tells you the user where to get and what to give and which material to give. This increases your efficiency that हाँ आपका जो रास्ता डिफाइन होता है वो सबसे शॉर्टेस्ट पाथ है कि नहीं. इट इम्प्रूव्स योर प्रोडक्टिविटी क्योंकि आपको पहले से पता होता है कि ये वाला स्पूल इतने टाइम में खत्म होने वाला है. देन यू कैन ऑलवेज ब्रिंग इट फ्रॉम द वेयर हाउस. एंड ऑफ कोर्स when you improve the efficiency and productivity you will always get a return on investment because आपने जितना पैसा लगाया है इंडोर पोजिशनिंग सिस्टम लगाने में और ये सिस्टम बनाने में कि हाँ आपको ऑर्डर ऑटोमेटिकली जनरेट हो, your productivity increases, कम टाइम में आप ज्यादा प्रोड्यूस करेंगे and you will get the return on investment. Okay, so this was on the manufacturing side. Any queries we have?
Any queries? I don't think so. Mr. Bajpai, you can continue.
Okay. Now coming to the supply chain part, we have, okay. How much time, Mr. Drave, we have more? I think my 1 hour is over.
You can take your time, Mr. Bajpai. No worry.
Okay. Okay. So coming to the supply chain, now you have manufactured your product, you have designed your product, then you have manufactured your product, and now it becomes absolute necessary that it has to be delivered to the end product, end user in time. It has to go to your suppliers or your customer who have ordered this in time. So what all different technologies right now are impacting the supply chain? We have smart spaces, we have blockchain and distributed ledgers. I think you have talked about this in more details. We have hyper automation, and then using AI and ML, how we can improve our supply chain. So I start with this smart spaces first. So smart spaces basically means that they are the physical locations. They are simply a physical location which is internet enabled. You have different sensors, and these spaces are being monitored by your intelligent sensor or intelligent technology. How does it? For example, a very simple example is you have a building. You have a big building, and there you have a temperature sensor in every floor, every different key areas, and then you know that okay, this is my smart space where you have controlled the temperature throughout the building. So this is very simple example of being a smart space. It can also be like a smart city where we say that okay, now in India we have most of the places, or increasingly more places, are having the LED technology. So you have LED based street lightnings, and based on the real data, like how much sun is shining, how much when is it night or when it is day, you can turn on and off. That was old. Nowadays you can also have that okay, you can adjust the brightness of these LEDs so that you save the electricity. These are very generic example of smart spaces, but when I talk about this supply chain, one example is that okay, you have produced a good which is perishable, like food products. आपका जैसे मीट ट्रांसफर होता है, फूड ट्रांसफर होते हैं आजकल, दे नीड टू बी इन स्टोर्ड इन लाइक सी फूड को एक टेम्परेचर, कोल्ड टेम्परेचर में ही रखना है. इफ while transportation these temperature goes above or it's more hot, then the seafood becomes waste, एकदम बेकार हो जाता है. So while doing these transportation, we have a smart space inside a truck. We say एक कूलर ट्रक आते हैं कि when you are driving, you are in a truck, you have a refrigerated trucks or a refrigerated trailers to it. Or how that becomes smart is we put a sensor and we collect it to a cloud. Simple. कुछ नहीं करना है ज्यादा, एक सेंसर लगाना है, एक क्लाउड से कनेक्टिविटी देनी है, and then the customer who has ordered this product, or the customer or your manager or let's say the quality guys can monitor कि हाँ आप जब ट्रांसफर कर रहे हो, ट्रांसपोर्ट कर रहे हो, throughout the time the temperature of the product was maintained, so this is still good to eat, or it is still having a good quality of the perishable good. Yeah. एक और example होता है आजकल which we were also talking in with Indian Railways. It was about monitoring of those ट्रेन कैब्स, या मतलब एक ट्रेन में होता है कि कुछ कैब्स होते हैं, कुछ बोगीज होते हैं जो मालगाड़ी होती है, उसकी एक बोगी आपको जानी है अमृतसर, एक जानी है आपको साउथ में, एक जानी है आपको वेस्ट जोन में. सो डिपेंडिंग ऑन दिस, द आइडिया what these Indian Railway guys had was that they put a sensor on it and connect it to the cloud. So उसमें ये रियल टाइम में ट्रैक कर सकते हैं कि जो मटेरियल, जो माल इन लोगों ने लोड किया है उसमें, या जैसे a customer is there, I have sent my big load of 12 tons or so to some location. Now we can track, or that guy can track कि अभी उसका माल कहाँ पे है. So the और रेलवे को ये फायदा है कि they would know कि भाई this bogie has gone into this train, this bogie or this material is standing in this yard, and through that they can plan कि this from this yard this bogie has to go into this train at this time, and through this they can do the planning of the material and the real time say. And they यूजुअली क्या होता है, एक बंदा जाता है पूरे ट्रेन में चक्कर काटता है, पूरे यार्ड में घूमता है, देखता है कि भाई वो बोगी है कहाँ, खड़ी कहाँ है, उसको इस ट्रेन में लगी हुई है, एंड देन ही टेल्स द ड्राइवर ऑफ द यार्ड इंजन की भाई ये बोगी निकालो और उस ट्रेन में लगाओ. सो उसका एक एडवांस वर्जन ये है कि आपको अगर सेंसर लग गया तो आपको बैठे हुए ऑफिस में पता चल जाएगा कि हाँ आपका ये बोगी और ये मटेरियल और ये कार आपकी उस ट्रेन में, उस यार्ड में, उस ट्रैक में खड़ी हुई है, एंड यू कैन जस्ट सिंपली पुश दिस इंफॉर्मेशन टू अ यार्ड इंजन ड्राइवर एंड ही कैन पुल इट आउट एंड पुट इट टू अ राइट ट्रेन एट द राइट टाइम. इससे आपका टाइम बचा, इससे आपके जो मटेरियल्स हैं वो आपके एंड प्रोडक्ट और एंड डेस्टिनेशन में पहले से जल्दी पहुंचेंगे, एंड द चांसेस ऑफ गेटिंग इट लॉस्ट or getting it delayed has been reduced. So this is one example of smart space, what we have been seeing the trend nowadays. Blockchain distributed ledgers, I would skip this because you already know this a lot. So ये आजकल use हो रहा है digital property records में, smart contracts में, healthcare में. So these are all the sectors जहाँ पे आपको complete transparency चाहिए and traceability चाहिए, कि आपको दिखे कि हाँ the orders were coming from here, the payment have been made, and we also know that okay कि जैसे healthcare है तो उसमें it's illegal that कि आपका medical record कोई और alter कर दे. तो it has to be like clear throughout कि every vendor needs to know that कि हाँ these are the payment records, these are your health records, and these are things. So it should be immutable, and this is where the blockchain technology is helping. So I will skip this, not go into much details. Coming to the hyper automation. Hyper automation technology is mostly not a technology itself, it's like a mix of technology. Hyper automation means that you take a part of technology or something which is already in your company. So you have already invested previously in some kind of technology before. You take this technology, you mix it with some part of the new technology, and then you have got a hyper automation. You can reuse your old technology, new technology, and yeah, you can reuse your old technology and get benefits of new technology altogether. It's kind of an enterprise resource planning ERP system where it's a mix of technology, and the best point is that you can customize what you need, what you want to get, and you can create a optimized solution for yourself using this hyper automation. Okay, this is hyper automation is a very generalized word for automating your complete supply chain or operations right now. Coming to the AI and ML, of course, it's pretty clear now. We have a when you want to supply something, you want to order something, or you want to maintain that, okay, these suppliers have raised these purchase orders, these are the payments that needs to be made. The data or data has been generated, and we know that sometimes it becomes very complex that, okay, to track how it has been used or where it has how to track these all different parts. Yeah, it becomes very complex. Or sometimes you have also need to know that, okay, these are the different example dunga main. You need to know that, okay, there is a driver who comes logistic. So there is a truck which is working in 3 shifts, like 8 hours shift for each driver. And then the system knows that, okay, this guy will be working during this point, and this point. And usually this driver covers like 4 stops to 10 stops per shift. And that's why the system will generate order for him that, okay, this guy would need, the system would learn the driver's behavior, and they would tell over that, okay, these are the packages you need to take up from the warehouse, and these are the packages in the different direction or areas you need to deliver, depending on that how quick this delivery needs to be made, what is the priority, and how fast the driver actually delivers this, and how in a good quality he can deliver it. So this is how the AI and ML can be leveraged for the supply chain. Here I have again a hype chart for the supply chain. Here we say that, okay, here you can see we have already certain topics or certain new upcoming emerging technologies here, like blockchain supply chain. It has crossed the innovation trigger. That means now we have certain success stories with the blockchain in the supply chain, and we also have certain failure stories. And the first generation of the products are to be upcoming in the market soon. And you can see that we predict that into 5 to 10 years it will reach the plateau stage. Yeah, and the new upcoming models are like natural language generation. The user calls up and he says that, okay, I need this order, and then using the natural language, order or a purchase request has been generated. This is one of the upcoming new breakthrough technologies. We say that in 5 to 10 years would reach a commercial viable product if it crosses these next two stages. We have Internet of Things also here. So you can see that in the supply chain technologies, now we are going to see a 2nd generation and 3rd generation of the products to monitor the supply chain and have a cloud connectivity. And sitting at your home, you can see that, okay, where is your product, how it is there. And the smart spaces things are basically reaching its 2nd and 3rd generation of the products. So this was about smart chain technology. One example I have is right now, I think this was a use case of using nanobots in a warehouse was made very public, and it was started by Alibaba. I can say this, and you would see a lot of press release and news release that, okay, Alibaba is going to have this smart warehouse management where small bots are running and they are generating your packages. Nowadays, I can also see that it's adopted in Amazon, in DHL, and other delivery services. So how it works is simply you have a list of order or list of things, you feed it into the system, and the system knows where the different materials are kept in your warehouse, and it simply sends a bot to collect all those, and finally it delivers you like 5 to 10 packages. But when you're talking about startup and want to invest in a technology like that, this is pretty costly because you have multiple robots running around your warehouse, and you need to have a big warehouse with multiple orders coming in to make this technology more profitable. But there is also a simple version also of these technologies saying you can have a tag which is a Bluetooth enabled and a smart, and you can tag each and every rack or a material where you are keeping it. And when a user wants to, let's say, go into the warehouse and get the list of orders, which he has got recently, he would simply follow those Bluetooth tags using the Bluetooth indoor positioning system. In your app, you will get a mark that, okay, these are the areas where the things are kept, and you do not need to search your whole warehouse that where it is kept. So using this technology, and this is like not a very costly technology, but still you can leverage it for increasing your or reducing your time to delivery or time to send it out. Okay. Lastly, now we will talk about the services. Services, there are like 4 trends which are ongoing. So basically it talks about the customer service, how good you feel, make feel of the customer, that customer feels that, okay, I feel good about this product. Whenever there is a bad thing or there is a query or there is a feedback you want, then the customer services are very important to make sure that the customer is happy and your product is up to the mark, and you can always get a real-time feedback so that you can improve your product in the future or next generation of the product lines. So I guess most of you have seen the chatbot already. So the chatbot has reached its plateau. It is now a commercial viable solution. There are a lot of services like software services which are being offered on a commercial scale, and you can simply buy these services and use them as part of your customer service experience. So basically chatbots are like when you have opened a website and simply when you are searching for a product in that website, there would be a pop-up message as a text message saying that, okay, hi, I am this guy, do you need some help? So this is kind of a support system that, okay, if you are sure this is a potential customer who has visited your site, and if his queries are answered, then you would know that this potential customer can be converted into your actual customer. So the chatbots also help you in this direction. And sometimes it is that the user had got a problem, he has bought your product and he's not sure that, okay, where to contact, how to contact for his queries. So these chatbots also would be your first line of interaction. It says that, okay, I don't need to have a 24-hour service, customer service or something, but when using these chatbots, the general FAQs are answered. So if it's a general thing, the chatbots might answer. If it is something complex, it will take the request and it will forward to your team. And the team, when they come back into the normal working hours, they can still respond to these queries. So in using these chatbots, you will never miss or you would have a reduced risk of having a customer which is not getting his answers or not getting himself heard. So next technology is about mass personalization and micro movements. Most of us has already seen this. If you are doing online shopping, you can see that, okay, based on your shopping trend or searching, you see that, okay, there is a customized and a personalized request or offer which are also suggested to you. So these are the technologies where we say that, okay, for the masses, for the complete huge population, you personalize for each person and give him the more data or suggest him something that, okay, this kind will be useful for you. Micro movements on this direction means that what you have is like customer, he is like using your product and suddenly he faced some issue. He might be angry, he might be confused what's happening. And at that point of moment, he will simply just call up a service, your customer service, or he would directly go to your website and start searching that, okay, where he can get the answer. If in that moment, your product gives a pop-up or it says that, okay, hi, can we help you out? This becomes a micro movement. So you are helping your customer in the real time at the exact moment when he needs a help. And these technologies are like via phone, chat, or SMS. It can be anything. It can use any method, but these micro movements are the movements which defines that, okay, the user might not get from a satisfied customer to an angry customer. And yeah, this is how you keep or maintain your customer base. Next comes the big data and augmented analytics. Yes, earlier we used to see that, okay, we had a small data, and for example, let's take a stock market. So stock market, there you see the person in 90s or 80s, you see if the person has more data with him, he can analyze the trend on his own, he can make millions of money. Now it has been automated. You have a huge set of data, you have many customers, their different requests, their different searching pattern. You have a huge set of data, and then there is the analytics which is running on these data to find out, okay, what are your potential customers, what are the customers who are looking for a second product or an upgrade to that product, or what all data or add-on services these customer would need from your side. And this would increase the customer experience for your product for these customers. And when you combine all these three things, then you get a voice of customer. That means this technology means it takes input from multiple sources. It goes online, it checks the reviews the customer has given, the feedbacks they have given, there are different forums where customer speaks, there are different customer surveys. And when you include all of this together, like clicking, how many people visit your website and how many actually buys, all this analytics combined together makes voice of customer. It means you understand what customer needs, you hear him out, you see that, okay, this might be the issue, or this is what the customer is also looking for more. And what happens is, once you know this, you can always improve the second generation of your product, or directly contact customer and make him feel that, okay, your product is can be utilized in more efficient way, or how to make that customer more satisfied. Yeah. So next we see the hype graph of the customer services. And here you see that the chatbot, this is from 2021, the chatbot has already reached the trough of disillusionment, and we see that the second generation of the chatbots are already in the market, or they are trending towards the market. Yeah, I think most of us have also seen that in Amazon right now, if you call them up, you see that the agents are working from home also. So this is also one technology which has already reached the plateau due to the corona, that all the service agents work from home, from their comfort home, and they are still able to answer all your customer queries. So these are the different technologies like voice over call applications, speech analytics, customer service analytics, and they are right now on their first generation and on the process of getting adopted. So if you look to the graph, you can make decisions that what technology would be best for your startup. Okay. Then this would be all from my side. I hope some of you would have got some inputs from me, and it would have been a successful session for you guys.
Thank you, Mr. Siddharth. Let's wait for a couple of minutes. If we have any questions, then we can take them. Anyone has any question or any query so that we can take them quickly before starting the next session? Okay. So I think we don't have any questions. Yeah, but yeah, thank you very much, Mr. Siddharth, for explaining everything in a comprehensive manner. Okay, we have one question, sir. We can outsource most of that.
Most often, yes. The idea was that nowadays we are moving as in the service sector. That would mean that in the startup, not everything you have to do on your own. If you start doing the complete supply chain on your own, it would be, it would be a mess. So idea would be that we leverage the technologies and the services which are already offered by the companies. Most of the time it works for us. Sometimes, we need a customized solution or something which is very specific to our needs. And in these scenarios, it's a decision or a balance we need to make that, okay, if we go ahead in this direction, will it suit our business model or not? So I would say it's a business model decision that if outsourcing works for you, or it is that, yeah, you develop on your own. But world is moving towards services, and it's better that we take the leverages of these services.
Okay, I guess that answers your question, Gitanjali. Okay, so external manufacturing is successful on small products. We have another query.
Yes, if you are more detail, or you have to be comprehensive when you are choosing the external supplier, because the manufacturing process will determine the quality of your product. Means how you are going to how your product behaves in field. So you have to be very comprehensive when you choose the external manufacturer. But for the small products, it's much more beneficial to have external manufacturing.
Okay. Mukul Chaudhary has raised the hand. So, Mr. Bajpai, you can unmute him and then we can take his query.
Yeah. Mukul.
Yeah, Mukul, you can raise your queries. Yeah, please.
Okay, I think he has some troubles.
Connectivity trouble. Okay, any other queries?
But
Audience,
for
any other
more
queries, or
branches,
else we can end this session and we can roll to the next session. I guess we have accommodated all the queries. Thank you very much, Mr. Bajpai, for the insightful session. Again, you can expect queries in future too related to the technology and how it is changing the ecosystem. So with your kind permission, should I share your LinkedIn account with the students so that they can contact you, industries, they can contact you for further assistance and further clarifications?
Yeah, that should be fine. Just drop me a query. I don't know when it will be answered, but I would try to answer them, of course.
I'm sure. Yeah. Thank you very much. And I know that you have spared your time out of the work and everything, and that too on the weekend. Thank you very much, and we expect this kind of interaction in future too. Thank you.
Sure. Thank you, guys. Bye-bye.
Okay, so we'll have 2 minutes of break because next session is all about how to develop an application, and rather than application, how to plan a business, whether it's a new product, new services, or even how you can analyze your investment, because we are doing it for MSMEs, we are doing it for new ventures. So it's very important to understand whatever investment they have done or whatever investment they are planning to do is how feasible. And again, when it comes to business, many things or many theoretical concept is not applicable because of so many things, because of the external ecosystem, because of the internal constraints. So our motivation or our way of empowering the new businesses and new ventures or MSMEs, like to identify the right fit of technology for their product development, for their product support, or for their business support. So in this session, I'm going to talk about the blockchain technology. And why again blockchain technology? Because from yesterday's session and from the morning session, it was very loud that students and the MSME, the whole industry is actually very curious about the blockchain. Now, the blockchain is an umbrella term, right? Because and trust me, we have a very primitive understanding of blockchain. So I'm going to talk about the blockchain and specifically blockchain in healthcare, because healthcare is again where many companies are actually jumping, or many companies are actually putting their resources to develop services and product. The purpose of this workshop is to make you understand how can you pick the right technology, or even a component of that particular right technology, to make you aware that what is the development when it comes to blockchain in healthcare sector. So in next 2 or 3 minutes, we'll have a break, and then I'll start how to actually understand and how to actually plan your blockchain investment for future or in the coming times, which can be helpful for you to sustain. First of all, sustainability is a very important aspect for the ongoing businesses. And then again, for the new businesses, the upcoming businesses, because that is something which actually sets your course for the next 5 years. Okay, so in next 2-3 minutes, we'll start the session. I hope you guys can take 2 minutes of break, and then we'll start the session.
Hello.
Hello.
Hello. Sir, session is over.
No, not yet, not yet. One session is left. Okay, we have taken a 5 minutes of break.
Okay.
Yeah. Okay. So hope my screen is visible to everyone. Vikas, is my screen visible to everyone?
Yes, sir.
Yeah, it's visible.
Okay. So now this is the final session, and rather than calling it a final session, an important session, because in the morning we have understood how the patents is actually helping ourselves or us to understand the course of the technology or the future course of the technology. Now, when it comes to the technology investment, it is very important to understand what technologies are going to evolve and what technologies are there on the course of maturity or even decline. Now, once you understand that, okay, this is the course of the technology, then what will be the next step? Should we jump, or should a company jump there and just do the technology investment? So let's take an example of this blockchain only, blockchain technology, right? Nowadays, it becomes a jargon. Everyone is talking about blockchain, very fancy word, very lucrative technology. People treat it as a disruptive technology. Some companies, MSMEs, they are actually running behind this particular thing. But the whole point is, even if you get the technology, how confident you are to leverage its maximum potential. And when I'm talking about leveraging, I precisely talk about the ROI, right? You can calculate the ROI in terms of the sustainability of your product, service, business. When it comes to ROI, the profitability. And the most important thing, what kind of a unique proposition you as a MSME, you as a business owner, you as a particular, you can understand, a young brain can actually leverage. Okay, so someone has actually raised the hand. So, okay. Although I prefer to have questions in between, but yeah. Yeah, please. You're unmute. Do we have the question? Okay. No worry. So the point is, the blockchain is something which is a most discussed technology, right? So we have two technologies in the current time where companies are actually doing the investment and a heavy investment, right? One is blockchain, another one is IoT, Internet of Things. These two technologies actually changing the course of the whole industry. And when I'm talking about industry, it is not specific to a particular industry. All industries, they are actually adopting these two technologies, but for a different purpose, right? Because both the technologies have their own radius of spin. Both the technologies have their own merits. Both the technologies have their own demerits. So today we're going to understand whatever mined or patents we have mined for the blockchain, how that particular thing will actually help the MSMEs to plan their products, to plan or to forecast or create a blueprint for the next 2-3 years so that they can do the right investment in the technology. Because once you made an investment, you cannot take your foot back, right? So this is why it is important. This is why. And if you recall our yesterday's discussion where we were discussing about anticipation model, it's not that easy. It's not that easy that, okay, you have a clear objective in mind that, okay, this is my product, this is my service, this is the segment whom I want to cater, and I can plan my strategies, or I can plan my structure like this. All companies, they start with this notion only. Majority of the MSMEs, they are doing the investment based on this notion only. But why then 95% of the businesses in Indian ecosystem, they are even not getting that kickstart? Forget about booming, forget about they are flourishing. They are not even getting a kickstart in the beginning, and that's why they are facing the losses. So the whole idea, whole purpose is to understand, and to understand a scientific way of adopting or making the technology decision in a greater manner, planning your product or services. So now, blockchain, healthcare, these two different things. Healthcare is the industry, blockchain is the technology, right? How blockchain is actually different as compared to any of the technology, right? So you understand, and you have a very primitive understanding that, okay, decentralized ledger, transparency, connecting every nodes, connecting the stakeholders, that is, we call it as a blockchain. Many permissions, smart contracts, chains, right? Small blocks. This is the blockchain. And then healthcare. Why healthcare? Because now we hit by the pandemic. Now there is a money in the healthcare sector. This pandemic will be there, and again we can actually imagine or forecast this kind of a things in future also, right? So that's why healthcare. So any company can simply pick a blockchain, and then they can actually develop or start developing the services for the healthcare sector, right? Now think or imagine a condition where in a billion of in a population of 1.3 billion, and if you consolidate the whole market, right, into that, minimum 100 companies, right? And that is a minimum number. And that includes the young entrepreneurs, that includes the MSME. They are planning to rope the blockchain while developing or planning their products or services. So tell me, is it a great strategy? Because then majority of the companies, majority of the new entrepreneurs, they will end up by making the same solution. They will end up by making a very small market, because the market is limited, right? If you are understanding a market of 100%, and if all companies they are making the same services, the same products, then obviously they'll have a very small portion of that particular pie, the whole market pie. How to create a USP, how to create a novelty? Because then again, technology is same, right? Technology will not going to be customized for you. You can always plan the features according to the technology, but then again, technology will not going to change in a drastic manner for you being a business, or being a new entrepreneur, or being an existing business, right? So how intelligently we need to understand that, yes, this is something, this is the feature on which we need to build up our business, right? Again, these businesses, they also require the complementary support, right? So developing an ecosystem, a transparent ecosystem in healthcare requires so many small services. But the point is, we are not bifurcating these small services. The point is, we are only thinking about a technology which is competitive in the market, and then we are living in an imaginary world where we'll just rope in the technology and we'll achieve the success. No. And that's not the actual way the world is actually thinking. So if you consider any economy, right, whether it's Japan, whether it's China, whether it's Taiwan, any economy who is actually doing pretty good when it comes to forecasting the technology, when it comes to forecasting the requirement, when it comes to forecasting the world requirement, the market, world market, they are not thinking like this. It's not that, okay, technology is there, throw the money, rope in the technology, have the application, have the product, push that particular thing, and it will work. No, this is not going to work, and that is actually not happening, right? And that's where we are failing. So in today's session, and why I'm considering it as a workshop rather than just a kind of a speaking or one-way interaction, because then you guys need to understand where the problem is actually occurring. Where is the, means, you can say, bottleneck. And trust me, this particular workshop is not to change your technology strategy. This workshop is totally oriented towards change your thought process while thinking about a technology. So I'll start with this blockchain and healthcare, and before that, I will actually take few of the understanding and learning from the previous session where we discussed about the evolution of trajectory. Now, in morning session, we discussed how blockchain has actually gone into a change, right? First, it was got evolved in 90s, right? And now we are in 20s. So you can understand, in last 2 decades, we have so many changes in the blockchain. Can someone help me to understand why we are talking about blockchain now? Why we have not talked about blockchain in 90s? Anyone? Any questions? If you guys will not ask the questions, this will become only a kind of a talk. So this is something which is very practical in nature, and then I expect you all to post your questions, raise your hands, and then only it will be logical for you to adopt the thought process while deciding about the technology. Any queries, any questions? And I'm asking this thing, why we are talking about blockchain now, why we haven't talked about blockchain in 90s, why all the industries, they are actually, means, investing, or right now they are actually running for these technology. Anyone? Yeah, please, Ms. Bhatt.
Yeah, I will add on to this one. Because in 90s, the technology, the background of blockchain was just digital signature and hash functions. But what happened in 2008 is came Bitcoin. That is the Satoshi Nakamoto paper. It solved the peer-to-peer puzzle of decentralization. So that's when it was a like of breakthrough in that innovation curve. So before 2008, the blockchain was there, but it was fragmented in digital signature, digital authentication.
Right.
After 2008, after Bitcoin, it came as a decentralized, something that disrupted the existing ecosystem of businesses, bringing a decentralized model, bringing decentralized ledger and peer-to-peer services based on peer-to-peer transaction based on a decentralized ledger. So I think that's that because it disrupted the ecosystem by solving that Byzantine problem. By solving the decentralization puzzle. So that's what I want to add into this.
Exactly. And in this case, we can also understand that blockchain was there and even companies have used them, right? Although it was not that generic in nature, because now we are more we have that kind of understanding this, what is digital signatures, what are secured signatures, what are encrypted signatures, right? Because we are using these things in a daily manner, in a daily processes, or you can say in a daily business. But when it comes to 90s, these particular things like digital signature, or you can say particular keys, they are very specific to industry, or even in that industry specific to very small businesses, right? So again, if you talk about 90s and if you talk about the current time, obviously blockchain has evolved because the features and the product of blockchain has evolved in a significant manner, right? As you can see in front of you, from 1990 to 2000, that means a whole decade, there were only few changes, or there were only few products, like the software verification, distributed systems. So in totality, only two. Then again, from 2000 to 2010, the last decade, there also we have few things. But then if you see this, then in next decade, that means in the current decade, this particular thing has actually got distributed, right? So now the decade, earlier it used to take a decade to have the add-on features, but then in past decade, from 2010 to 2020, by 2015 also they have few features and they have few products, right? So now it is significantly evolving, right? But then again, even if it is significantly evolving, we have one more constraint in front of us. That means shrinking the product life cycle, shrinking of business life cycle, right? So again, shrinking of that particular thing will going to affect your technological investments, right? So even if blockchain technology looks very lucrative in the current time, it doesn't gives you the guarantee that your business will actually leverage the maximum potential out of your investment or out of your technological investment. And that's what we are learning, and that's what we need to understand, how you need to adopt a technology in a scientific manner. Okay, so again, I'm not going to discuss this again, because this is what we have covered in the morning session where we discussed about the mining of the technology. This is just to make you understand why we are considering the blockchain technology. Now, if you see the patents, and the whole workshop is actually based on the patent mining. If you see the patents, 80 patents, and 80 is a significant number, trust me. 80 patents, it is for digital signature and ownership. So, and if you see, majority of the services, whether it's digital banking or those who are actually facilitating the processes, right? The transaction processes and everything, they are using the blockchain technologies for creating the services related to digital signature or some kind of authentication, because patents are there. And again, these patents are different. So again, not all the patents are talking about only digital signature. Not all the patents are only talking about the security in the digital signature. Again, they have their different layers. They have their different purposes. The ownership model, right? That actually works in a different manner. But since they are actually constraining themselves, or you can say they are actually regulating themselves in the category of digital signature. Then we have another big cluster which deals with data allocation and authentication. Data allocation, we are living in a world of big data, right? Data allocation, data distribution, something which is very common in today's world, something which is equally important in today's world, because one particular person is connected to multiple nodes. Cautiously, uncautiously, they are connected. We all are connected, right? So that's why. Then again, we have third cluster. That means computer software verification. And in the morning only, we have this example where Gujarat University, or one of the prominent universities in Gujarat, they are actually using the blockchain technology for verification of the documents. That is a degree. So like computer software verification systems are there and they are actually booming. But then if you see, we have 10 patents for that. That means there is a potential for these kind of services in next 5 or 3 years, right? Then the fourth cluster, we are talking about distributed and decentralized ledgers or the transaction. Now, everyone or every company who wants to adopt a blockchain for the new product development or for the existing business, they are only talking about decentralized ledger. But then, do you need to invest into that? Because if means your particular company can create a competence by going for digital signature only. And even if they want to develop some kind of a services dealing with decentralized transaction, what kind of a complementary features they require? So here, if you see all the 5 clusters, they are the complementary products. These are the products of the blockchain. Companies need to understand whether and based on their capacities, based on their objectives, what specific features they want to incorporate so that they can create a competency for their business. Right? So cluster 4 and cluster 5, secure user access, distributed. Now here, if you see, in totality, they are talking about 2 things: transparency and security. This particular whole blockchain technology is talking about 2 things. But then, do you really require all the 5 features for your services? Do you actually require all the 5 products to be incorporated in your product? Because the market is different, because the market requirement is evolving, currently evolving. You don't need all these services for any of the e-commerce company, right? So e-commerce businesses, they are booming in India, right? Although not everyone is getting the profit, even majority of them, they are they are finishing by getting huge losses. But then a small business, e-commerce business, they don't require all these particular product or the features. So why you want to incorporate them into one product? Why you want to have the technology investment for creating all these products? That's the question. Okay. Now, if you talk about the application, blockchain, again, blockchain is actually accepted by many industries, many sectors, prominently in fintech, supply chain, where the smart supply chain, connected supply chain we are talking about, energy sector, healthcare sector. Obviously, we're going to talk about the healthcare sector. Government organization, government bodies, they are taking benefit of the blockchain technology. Retail and consumer, again, to track the supply chain or to track the fashion. These retailer consumers is actually using the blockchain technology. Media and entertainment, because transparency is very important there. I don't know how they are doing it, I don't know, but yeah, they are also looking forward to have the benefits of the blockchain. So that is the application part. Now the technology, right? So what is actually blockchain? When we talk about blockchain, how blockchain is actually complementing the other technologies, or how you can club the blockchain into other technologies. So again, when we talk about blockchain, that doesn't mean it will not going to include or not going to complement with the Internet of Things. You can, right? Depends on the capacity, depends on the features, depends on the requirement, right? But then You cannot simply go and pick, okay, these are the options available and this is the best, or this is something which I heard the most and I can go for this. No, it doesn't work like this. And trust me, in the ecosystem, people are doing like this. Amazon is using Internet of Things. Every small e-commerce player, they want to incorporate the functionality of IoT or blockchain into their operations. You simply can't. You can have the technology. Again, trust me, you can have the technology because technology is readily available in the market. And companies are actually preparing these technology to fool the MSMEs, to actually make them to buy these things. But MSME need to have that kind of a knowledge to understand whether it's only investing in the technology is the key to the success, or it is something more, or it is something which starts much before than the investment and ends much after the investment. MSME need to understand this. And not only MSME, even the new businesses, new entrepreneurial minds, they need to understand. And that's why for a student, that's why for the researchers also, this is a very important thing, right? So blockchain can be clubbed with Internet of Things, artificial intelligence, big data, and these are also giving inputs to the blockchain technology, right? Because blockchain technology is not working as a standalone technology. It also requires an input. It also requires an infrastructure, right? So cyber physical systems, smart manufacturing, cloud computing, all these are the complementary things, and somewhere, somehow it becomes the products, or you can say the complementing technologies too. Now, and this is the important thing, how you can take the decision, how you can understand the technology, right? So IT ecosystem, and I especially want to comment here that the Indian ecosystem, although we discuss so many things, right? The Indian ecosystem is not that well versed or not that tightly coupled that any technology can be roped in a minimum time, or even to actually make it operationalize in a minimum time. No. So blockchain technology, let's suppose you are actually buying a blockchain technology developed by IBM. Perfectly fine. IBM is the front runner in that particular business. You can actually take the advantage of them and you can buy a technology. But your stakeholders, those who will going to use this technology, MSME, new businesses, they will definitely going to interact. They will definitely going to connect with the stakeholders, right? Now imagine a situation your stakeholder does not carry that competency to even complement the acquired technology. What will going to happen? Do you really think that particular supply chain will work? No, because that is a constraint. That is a constraint that the IT ecosystem, or you can say the digital infrastructure, the whole digital infrastructure is not uniform. It will never be uniform, because those who are sitting there on a beneficiary position, they will evolve themselves in a very exponential manner. In a very exponential manner, that means even the small companies, the small firms, they are evolving on a daily basis. They can't touch them or they can't reach them in that particular certain period of time. Why? Because of many factors. And the first factor is the scalability factor, right? So IT ecosystem is the first thought you need to understand whenever you think about the technology investment decisions. What kind of ecosystem? And trust me, in interaction with the MSMEs or by analyzing the MSME environment, they are doing good. But the point is, the IT infrastructure or IT ecosystem is not uniform. Right? It's not uniform. So we need to make our derogatory decision here that, okay, this particular technology, something important, this particular technology can give us the edge, but then whatever partner we are choosing, they are also comfortable with that particular technology. So first framework, if you want to understand how to rope in a competitive technology or a blockchain technology, is to understand the IT ecosystem or the digital infrastructure. Second one is the roles and the relationship to the core technological innovation. As that's what we have brought. Whatever technology you are thinking about, right? What is the actual role of that technology with the change of the innovation, right? Blockchain technology again evolved, or you can say a product of an innovation happened way back in 80s, then it got changed into a product in a technology in 90s. Now we have so many evolutions, we have so many products. But the point is, the current technology, how compatible it with the ongoing innovation, because we understand that all technologies have shrink life cycle. Any technology, disruptive technology, or you can say competitive technology. Let's take an example of 4G technology. When it came into the market, right, way back in 2019-18, right, that was be treated as the disruptive technology, because then Geo has disrupted everything, right? But the point is, has Geo completely replaced the process of communication? We need to understand, because see, disruptive technology can become disruptive and can sustain as a disruptive technology when it continuously change the processes, the business processes, the business operations. But the point is, every technology has its own peak and lows. So that is the main thing, that whatever technology MSMEs, whatever technology, the new ventures they are planning to rope in, is that particular technology is that dynamic, which can be comparable with the innovations happening in the market. Because so let's suppose you are planning to have the blockchain technology for digital signature, for the secure signature, but then you are witnessing that in the patent world or in the real world, the innovators or inventors, they are actually working on something different thing. Right. So although you're dealing with the current set of technology, although you're dealing with the competitive technology, but the feature for which you have actually invested in the technology, that is something which is already obsolete or on the course of obsolescence. So then you cannot say that, okay, my particular business will going to sustain for the next 5 years, because already it started obsoleting. So that second thing is the role and the relationship to the core technology innovation. That is most important thing. Third parameter, or you can say the crucial parameter in the framework, is the pattern of technological change. How the technology is changing. And I'll take this example here. If you carefully understand the time lapse between the barcode and RFID technology, the time between the two was very small, right? But the investment was a huge difference, because for creating, manufacturing, or you can say sustaining, for barcode, it's comparatively very nominal as compared to RFID. Because in RFID, you have to service the chip, you have to manufacture the chip on a different style. Then again, the maintenance is a different issue, right? So in that sense, both the technologies are there, and they were actually working parallelly, right? But then once you invested in the barcode technology, you cannot directly jump into RFID technologies, and vice versa. But the point is, the difference between the two technology was very, very, very small. In similar manner, if you are investing, or if you are developing, or if you are starting developing a product which is directly related to digital signatures only, because now the market is booming with the e-commerce businesses, the market is booming with the authentication of the documents. But again, that is not something, or that might be not something which will be a kind of a front runner in next 2 years. So wait, don't invest by seeing the current market, because again, that is an anticipation mode. And that's where we are failing. That's where the business, the whole ecosystem is not developing that kind of a thrust that, okay, now whatever is our investment, it is based on the accurate forecasting. No, it is based on the anticipation forecasting, right? So that's the 3 points. Whenever a business, or even the ongoing MSME businesses, they are doing, they need to understand this first, and then after you need to go, or you need to jump for the technology investment. Now, the role in the IT ecosystem, right? Now, because that's a very important thing, right? That's a very important thing where companies need to understand, right? So technology also changes their position, right? When it comes to changes of the position, sometimes technology becomes your product, sometimes technology becomes the component, sometimes technology only plays a role of an infrastructure, right? So in the case of Paytm, technology has become a role of a product, right? Technology has become a role of the product. But when it comes to the technology for different businesses, let's suppose we are talking about something like, let's take an example of component first, right? So any technological change like M1 chip, let's suppose M1 chip, Apple is actually producing M1 chip. Now they are producing this indigenously, they are producing it in-house, right? But that is not the product they are selling to the market. The product they are selling is their laptops, their phones, their iPads, right? But that component, that is a technology, is actually become so competitive, and they are actually complementing the products, or you can say the new offerings or whatever services. Because even if they are rolling out the services like Apple Play, Apple Music, that is also happening because they have a good set of technology. Any questions till this time? Do we have any question? Okay, no way. Okay. So very relevant question. If we understand that government is actually posing a strict regulation when it comes to blockchain, or when it comes to these kind of a transaction, and then we have heavy transaction fees in the form of, you can say, taxes, right? 30% taxes. But here, these particular taxes or these particular regulation will be only applicable where we are converting these transactions, or we are converting this digital money into some kind of a physical thing, right? Now, if you talk about cross-border interaction, or if you're talking about cross-border businesses, there, many other world countries, they are actually allowing the blockchain to be incorporated into their transaction systems, right? So government is actually putting the regulations for the businesses, those who are actually doing in their business in the Indian ecospaces, right? Now, it will be very difficult for the MSMEs and the new ventures if they are only working, or if their partners are only from the Indian ecospaces. But then if your partners are coming from Vietnam, if your partners are coming from the other Asian countries or the European countries, they don't have that kind of thing, because the foreign policies are different. The foreign policies are different, right? And that's what I'm saying. It's not that very easy for the MSMEs and the new ventures to directly adopt and go for the blockchain technology. No, it will not going to happen. So blockchain architecture is something which is not unique in nature, but what kind of a stakeholder they are, means blockchain technologies are using, that can be customized and tweeted according to the constraints, according to, you can say, the feasibility of that particular technology, right? So that's that. But again, that's a very relevant question, because now many companies, they are facing this particular challenges, right? And they have already invested in the blockchain technologies, and now they are facing, because of much of these particular you can say taxes and everything. Okay, so product, first of all, technology as a product, second, technology as a component, third, as an infrastructure. Like many companies, they are developing the infrastructure, and this infrastructure itself becomes a product, right? Technology first used for developing a kind of a structure, and that structure will going to complement the other businesses. But you can say that indirectly, that infrastructure is also a product for a particular company who is actually manufacturing or even furnishing that particular structure, right? So, but again, that is not something which is actually required. So I'll take an example of Amazon Web Services, right? They are actually creating an ecosystem. They are actually, so Amazon is actually creating an ecosystem. So in one way you can consider that, okay, Amazon Web Services, it is an offering, it is a product. But on another sense also, whatever technology they are bringing to the market, it is providing a infrastructure, or you can say the complementary infrastructure for the whole market. Nowadays, majority of the companies, they are using the Amazon Web Services. Majority of the companies, they are using the cloud services, right? These services actually gives avenues to many small and medium businesses, many new businesses to think about the new products, right? So this particular thing, we need to understand the roles of like how technology act as a product, act as a component, act as an infrastructure. Now, this is what we have just taken, right? So technology that interact with the users in the given context of use, they are built up for the component technology that we consider as a product and the application of that particular technology, right? We have an example also, the IT ecosystem centered on digital music playback. MP3 player would act as a product role because it interact directly with the user, right? User can actually touch the technology, user can actually experience the technology firsthand, right? That is something where we call it as a technology as a product. Then a component represents technologies that are subunits or subsystems of other technologies in an IT ecosystem. For example, RAM, and that is a very classic and best example to understand the technology. So we have SSD RAMs, we have other components, computer components. Now we have like M1 chip. Just now we have understood M1 chip, right? So these particular components came out of the technological innovations, came out of the exponential change in the technologies, came out of the change in the structure, architecture of the technologies, right? This is something we call it as a component. So these technologies, they are working as a component, and they are not only perishing the parent companies or parent businesses, but they are also perishing the other businesses in that particular ecosystem too, right? So now M1 chip is actually used by Apple, but then in future M1 chip can be used by or can be outsourced to many other companies. Who knows? Similar, if you talk about the Samsung actually makes OLED displays for most of the mobile phone companies or most of the electronics companies. So that OLED technology was developed by Samsung, and it is now leveraged by majority of the electronic manufacturers. Right? So in similar manner, component technology can becomes the component. That component will actually going to transform the ecosystem, the whole sense of the ecosystem, you can say. Then the last one is the infrastructure role. We have already discussed, describe technologies that enable or work in the conjunction with the product and the application role of the technology. So the best example now, Zoom or whatever. So this wireless connectivity technology, first of all, the original technology was the wireless connectivity technology. And then how this particular technology is now staged to a particular thing where we are using this MS Team or Skype or even Cisco as a platform, right? Yeah. Exactly. Utilizing the Amazon Web Services cloud. Yeah, exactly. So that's what I'm saying. So infrastructure is a very strong component. And the problem is our MSMEs, or you can say the new businesses, they are not considering this aspect of technology. So our understanding of the technology is like, okay, we can bring the technology, we can transform that technology, or we can actually lay out a design of a product based on that particular technology, and that product will be some kind of a services or a final product. No, why can't it be a component services? Why can't it be a infrastructure offering? And that's where we need to understand where we are lacking when it comes to MSME, when it comes to new business ideas. Right? Now, this is a very interesting pattern if you see how the technology evolves, right? So whatever technology it got started, and if you see how it interacted in between. So if you see the first, that is the product development thing, where the technology actually acts as C and P. And what is C and P? If you see, C is the component and P is the product, right? Now here, if you see, when it comes to product development, the most crucial thing is the, first of all, the component thing, the technology as a component and technology as a product, right? When it comes to product development. But when it moves to product and infrastructure alignment, that becomes the I thing, right? So product and infrastructure. So whatever infrastructure you are developing, that becomes the product, or that particular thing becomes the product. In similar manner, for feedback and feed forward, this particular role is going to change. So within a specific time of period, the quantity of the technology in each role determines the dominance of the role. So let's suppose, let's take an example of blockchain only. In 90s, when it started to evolve, that time, that might be just a component technology, right? Because that is something which can be used as a complementary thing with some of the existing services, right? So that time, that can be just a complementary technology, or you can say the component technology. But then if you understand, in today's time, the blockchain is a infrastructure. The blockchain is an ecosystem which you always required, right? Now the point is how we are understanding this change of course of technology. That is the important thing. That is the most important thing. Transition from one set of dominant role in the ecosystem to another set. This is very exponential. This is very dynamic. And being a MSME, being a new venture, we need to understand it much before than taking a technology investment decisions. That's where the industries are playing. And that's why if you see why Japanese company, why Chinese companies, or the Chinese ecosystem, the whole setup is actually booming and competing with each other, right? Because they are actually understanding the changing role and position of the technology in a very precise manner, right? So that is something which represents the role. Then the most important and interesting thing, because students and all the audience, they are interested into understanding the blockchain in healthcare. So if you see in this pandemic time, and before even pandemic time, because if you see the patent counts, it got started from 2018, and now in 2021 it is around 134. So obviously it is logical, after the pandemic, many industries, they have shown their interest, they have actually oriented their interest in such a manner that they are pouring their resources, or the major resources, in the healthcare sector, right? But it got started in 18, right? So major application of blockchain in the healthcare, they started in 18, right? And now we have around 134 patents, and again it is increasing in an exponential manner. Now if you talk about countries, those countries who are actually developing, or means you can say this particular thing, applications of blockchain in healthcare, US is the front runner. See the thing, 149. Then second is Canada. India only 13, right? So if we are not talking about the patents, and if we are not very serious about the patents, how can we actually plan the product? How can we actually plan the services? How can we actually plan the tweak course in the ongoing businesses, right? So that's why US, when it comes to services, and when we talk about blockchain, obviously US is a service economy. They are thinking about this, and that's why they are understanding the technology with a different prospect. They are analyzing the technology in a very deep and crisp manner. Now if you see the technology, right, and if you see the technology and this particular thing, US, they are majorly working on G16H 10/00 technology. So this patent, this is not a technology, this is a patent. What this patent is all about? This is the ICT specialty adopted for handling and processing of patient-related medical or healthcare data. Now, if you see, the point is, these particular companies, the US companies, they are actually doing their research They are actually doing their investment, technological investment, which is primarily focusing on the patient related medical healthcare data. So they are not actually means ailing the patient with the blockchain technology. They are not providing any kind of services, but what they are doing is they are actually leveraging the data, medical data, patient related data in the health sector, right, by using the blockchain technology or any new patents, right? In similar manner, if you see the second one, that is G16H 50 by 50/000, that is the ICT specially adopted for medical diagnosis, medical simulation, medical data mining. Second, ICT specialty adapted for detecting, monitoring, or modeling epidemic. Why? After SARS, right? Then this particular COVID-19, the demand for this particular kind of a services is enormous, right? Enormous. So companies in healthcare, they are actually developing or looking a product which can be related to these technologies, or which can be related to this kind of a patent, rather than just saying in a normal things like, okay, we will bring the technology to treat a patient. No, understand the use of the technology, understand the relevance of the technology, and understand how they are making the technology decisions, technology investment decisions, right? Then if you see the third one, that is G16H 20/00, and again G15H 40/00, they are mostly dealing with ICT specially adapted for therapies, improving plants for handling a prescription, for steering the therapies, monitoring the patient compliance. In similar manner, ICT specially adapted for management and administration of the healthcare. Now, in India, majority of the companies, they are developing the solutions, the services, which will going to help the administration of the hospitals. But the point is, that's not something which is very unique. That's not something which is actually with very specifically defined. Again, that depends. But then how this particular patent can actually help, right? Okay, you are a small firm, you are a MSME who can actually capable of developing one service out of this listed patents, right? Because these are 5 different patents that can actually cater 5 different services, or can be useful for developing 5 different services. Now, being a company and being a constraint in a ecosystem where we have a limited resources, why should you need to jump for all kind of these services when it comes to blockchain adaptation? Why not pick one service? Let's take administration only. You want administration. Don't go for patient related medical healthcare data. Don't go for detecting or monitoring of the patients or the epidemic. Just restrict yourself or your product, your services, which can be useful to administration, or which can be useful to managing the healthcare operations. The problem is, when we talk about a blockchain, we want to rope in and we want to develop all kind of features and services related to the blockchain technology. And this is where we are doing the mistakes. This is where we are actually creating a pitfall for all of us. We need to understand this. This is very crucial. This is something which is very important. Now, which company actually? Now, once you decided, okay, boss, I just want to go for the ICT application, or you can say the blockchain application, which will only deal with the modeling of epidemic or pandemic, or forecasting the pandemic. Okay, go with the IBM, and IBM is the best, and they can actually give you this kind of services. But does IBM is actually the best, or it is the best partner for you to provide you the solution? Like, it's the same manner that, okay, not every big name is really feasible for you to take or to consider as a service provider. No, it depends on what is your requirement. It depends on where you want to develop the product, in which specific segment you want to position yourself, right? Because then every operations, every investment will be around that only. Right? So you need to understand this particular thing. And for understanding this, if you consider the patents, here you can understand that 5 different companies, they are actually doing pretty good when it comes to patents in the blockchain related to healthcare. Right? Related to healthcare. Now, the point is, even when we have the count, even when we have this particular count, how can we understand that this particular patent can be adopted, or this can be the basis of taking this decision, technology investment decision? Because if you see the table here, what we have got after the analysis of the patents, so first of all, we have 5 different companies, those who are aggressively working on the patents or the innovation related to these particular services, features they can brought for while adopting the blockchain in healthcare. In all 5 different companies, they have different capacity, patent capacity, inventories, whatever. Again, here also, if you talk about the patent ages, right, and activity year. So here, those who have the maximum patent count here, the first one, right, they have the patent age of 2 years, and then the activity year is that means how frequent they are in rolling out the patents in that particular thing. That is relatively RN, means their capacity is 100%. So you should choose that particular company, or you should choose that particular service to go for. But the point is, we are not aware of all these things. Being a company or being a new venture or being an MSME, we are not following the scientific way of understanding or even talking about the technology, right? We are not, because this is something scientific in nature. This is something which follows a process. Now, again, if you come here, these 5 companies, 5 different companies, right, what we have discussed here, like Ping and Technology, International Business Machine Corporation, Frisians Medical Care, Patientry, Netspectives, all these 5 companies, they have their own bandwidth while doing the research and creating or developing the services, or even thinking about the services based on the different patents. So this G16H50Y, this is the same thing we have discussed here, right? So, and that deals with different features of the blockchain, or you can say the capacities, different capacity of the blockchain to develop specific services, specific products here. So if you see, the Ping and Technology is very good in, like, not very good, but aggressively working and actually putting the patents related to G16H50/100. So G16H50/100, that means ICT adopted for medical diagnosis, right? So if your MSME or your business requires to, or even if you are planning to go for a kind of a services which is healthcare services, means blockchain services in healthcare or any supportive services, they can reach to them, or they can actually use their potential competency. And out of this, you can also get a sense that, okay, what specific service even I need to develop? Because if you see, the maximum patent is coming for this 16H50/00, which deals with the potential while developing the services for medical diagnosis, medical simulations, detecting the pandemic or epidemic, modeling it, right? So why not to actually design some kind of a services, or think about this kind of a services that will going to help you to sustain for the next 5 years, rather than thinking a very generic service just by using the blockchain without any competency, without any that distinguished feature which can actually help you to even get a kickstart in the business, right? In a similar manner, if you see, in a decreasing order, if you see, we have other companies, those who are dealing, or we have other companies, those who are working on different features of the blockchain in the healthcare, right? So like 5th, Patientry, they have 5 patents, and for that, which patent? G16H10/00, G16H10/00, this one. ICT specially adapted for handling or processing the patient-related medical and healthcare data. Simple. If you are finding, and the best way of analyzing the whole chart is you simply pick how many patents are actually coming, right? And just cross verify with the existing service you have in the market. It's very simple. It's very simple. So you have n number of services in the market, n number of players, those who are actually roping the blockchain technology, creating the services, creating the products for the healthcare market. But then does those services is actually sustainable in nature? Currently, they are performing really great, but your technological investment decision need to stay there for a long time, right? Need to stay there for the long time. Now, my whole point is, while understanding the investment, you need to understand the course of the technology, and that course of the technology is actually visible by understanding the patents. The patents, if patents are booming, that means the course, the future course will going to be the different. If the patents are coming, that means you can expect the significant re-engineering when it comes to the process. If the patents are coming, that means you can expect much more functional product or services for the future, right? So if 15, that is G16H, 50 divided by 100, whatever it is, what specific patent it is, you should plan your investment. You can plan your product or service accordingly, right? Now, the next, this is something which we call it as the blockchain, means the patents we already have, right? The patents we already have in this particular thing, blockchain in the healthcare sectors. And again, many companies they are dealing with, and that's a scientific way of planning and discussing about the products or planning your product, future products. This is something which is, this is, I'm giving you so that you guys can understand how the patents is actually a scientific way to understand first what technology will going to be, or what will be the face of the technology in next 3 to 5 years. And next, what technology is actually feasible to invest or rope in. Third, if that technology is changing the course, what will be the design for my product, my offering, and for creating that design, what specific ecosystem is actually there. You cannot think about something which can't be complemented by the ecosystem. You cannot. In the previous session, few of the audience, they asked like, does this blockchain will going to replace the role of a facilitator? The whole thing is, it is still a question whether we can adopt the blockchain in the right manner or not. Why? Because the thing is, we don't have the infrastructure. And to understand the infrastructure, we need to understand the technology course, right? The technology course, how this particular technology course will going to change. So that's the understanding we want to give you in this particular initiative. That's the understanding we want to build up for the MSMEs and the new ventures, because anticipation model is something which MSMEs, which new ventures, which our thought process is actually following for a long time. If we want to take out ourselves with that particular old norms or old notion that 95% of the new businesses, they are failing, and why they are failing, then we need to understand the right way of planning the business and right way of planning the product or your offerings. So I'll end myself here, and then I wait if we have any questions or something related to scientific way of adopting or planning your product related to the ecosystem. The podium is open actually, and if someone has any question, please post their questions in the chat box, or they can raise their hand. Okay. Compete with the, yeah. Okay. Does the cryptocurrency have the potential to replace the traditional money? It is already replaced. I mean, see, cryptocurrency has already replaced the international transaction. You need to understand this. Why? Because of many reasons. Because the traditional transaction has many users in Bitcoin. Also, when it comes to cryptocurrency, they also have the users, but the sharing of that particular, say, monetary value is something very, very, very competitive in the blockchain. So already the international, or you can say majority of the transaction, it is replaced by the cryptocurrency and other forms of cryptocurrency, like we have Ethereum and other things, right? Now, how it is different from the traditional currency, you need to understand that the traditional currency is not dynamic in nature, and that means the value associated with the traditional money was not dynamic or is not dynamic. But when it comes to cryptocurrency, it's not about the transaction, it's about the dynamicity also, right? Because of this particular nature of the dynamicity, the transaction is actually becoming very, very, very smooth, right? I'll take an example. Suppose if you are dealing with the vendors from China, right? They deals in dollars, right? So they have their own currency. Again, the international currency is dollar. Our international currency, we also accepted dollar as the international currency, but there's always a difference between that. And again, that becomes sometimes the bottleneck, right? For the transaction, if you see, for the time, even though you are doing the digital transaction, digital payments, but because of this particular physical money, or you can say the standard money, what we used to use only, this becomes a bottleneck. Why? Because even the value realization of that particular money takes time. When it comes to value realization, that means from one economy it is going to another economy, and that economy, the acceptance, the same value of that particular money takes the time. But here in the blockchain, when it talks about the blockchain, or here when we talks about the cryptocurrency, the value of that particular currency is same. Why? Even after the taxes, why? Even after sharing of so many things in between, because we have so many blocks in between, the value is changing in a dynamic manner, right? The value is changing. Here, the value is not changing in the dynamic manner when it comes to traditional money. No. And that's why the difference, and to tackle with that particular difference takes a time, and that becomes the bottleneck, right? So it already, cryptocurrency has, means, I will not say that completely eliminated the traditional way of doing the transactions, but yes, it is actually doing. And as I answered to the previous question, how the government will actually regulate it, government tries to regulate it. And again, we expect better norms to regulate the cryptocurrency. But because majority of the transaction for the cryptocurrency is happening in the international territories or in the international ecosystem, that is something domestic government cannot stop. Right? Hope that answers your question. Do we have any other questions? Anyone? Okay. So I guess we have somewhere the whole, the notion for developing this workshop and this conference is to make the MSME understand and empower the MSME in such a manner that they can be more motivated towards taking the scientific way while planning their operations, ongoing operations, or you can say the future operations. At the same time, the new entrepreneurs, they can also plan their products in such a manner that the thought process will drive with whatever thought process they are carrying. That thought process should come in a scientific manner or after a scientific process. So that's the notion, or that's the motivation we have while designing this thing. And I really thank Department of Science and Industrial Research, who has supported this particular thought process. And our university, OP Jindal Global University, which is again a deemed university, got the status of institution of eminence. They also feel that yeah, this is something which is very important, and they have supported this kind of a thought process. And I'm pretty sure in future also we'll bring these kind of a program or seminal programs which can actually help the MSME, not only MSME. Again, when I'm talking about MSME, it does not mean that, okay, we are only focusing on the small businesses or medium businesses. Obviously, they are the part of the whole ecosystem, and we are talking about Atmanirbhar Bharat. So they are holding a major pie in the whole ecosystem. But at the same time, we are also empowering, or we have that kind of means you can say intention to empower the new ventures too, because they are in much crisis. They are not getting that kickstart only. So once you become MSME, you sustain there for 4 or 5 years, then it is easy for you to take the strategic decision. But the point is, the new ventures, they are not even taking off. And that's the whole problem. That's where our economy is actually facing the issues. So with this, I stop myself, and I thank everyone, those who have attended this workshop and conference. Hopefully, as this is the first initiative, this is the first effort from our side, we have given you some better understanding about the technology, competitive technology, blockchain technology, and everything. So those who have the queries or something, they can always connect with me or LinkedIn. And we always do these kind of analysis for different technology, specific to the industry, specific to the businesses. So in future, if people want our assistance, our consultancy, they can actually connect with us on LinkedIn. Thank you very much. And I'll end this particular session with this. Hope I have already taken all the queries. Yeah, thank you, sir. Vikas?
Yes, sir.
Yeah, we can stop the live sharing now. And
Okay.
because we are forming